With the toughest work completed, the crew of the Space Shuttle Endeavour is beginning its final spacewalk tonight. Then, a potential problem with the computer co-processor developed that could perhaps force a sixth walk. The computer glitch didn't dampen enthusiasm for what is being called a highly successful mission. About 15 minutes, CNN's John Holliman will be here to catch us up to date, tell us what they're doing and why. Stay with us. World News continues after this. And as we told you earlier, the fifth spacewalk is now underway. John Holliman joins us with all kinds of interesting models and gadgets and hookups.
Toys. We've got a lot to talk about, Susan, and not that much time, so let me just jump right into it if I can. The Endeavour's astronauts making their fifth spacewalk tonight, and what they're doing is right now Story Musgrave's out in the cargo bay. We've got some live picture to show you. While Musgrave is getting out on the robot arm, this is of course the Hubble Space Telescope as seen from the cargo bay. While we're talking, you'll probably see the solar panels that are rolled up, look sort of like rolls of paper towels on either side of the telescope. Those will begin to rotate out. He and Story Musgrave and his partner Jeff Hoffman will be climbing around the Hubble Space Telescope. They have a new problem to solve too. Last night, you'll remember, they added a new memory bank and a more powerful central processing unit to the Space Telescope computer. But today, that computer, which if you look sort of just above the word Endeavour on your TV screen, it's located in about that area, that computer doesn't work. Ground managers have disconnected it or turned it off. They think the problem could be caused by cabling, and during the spacewalk, they'll plug the new computer into the old one using a different connection port. Then the telescope operators on the ground in Maryland will fire up the new computer parts and see if they work. If they do, the astronauts won't do anything else. If they don't, though, the new computer will be disconnected from the old one permanently. Before they get to that, they have some other work to do. First on the list, replacing a black box which contains the brains for one of the telescope's pair of solar panels. This job is complicated by the fact that the box wasn't designed for astronaut servicing. Let me show you what it has on it right here. It has computer cables which are going to be difficult to connect using screwdrivers and spacesuits. The box is inside a door on the side of the telescope, and Musgrave and Hoffman will spend about an hour on this job. What they have is 3 computer cables that look just like this. Imagine, if you will, you're wearing boxing gloves, and you have a screwdriver, and you have to turn little tiny screws like these screws right here on the back of these 3 cables to hook up the new this new instrument inside. Wasn't designed for astronaut servicing, so they're going to have a very difficult job in doing that. But the ground managers say they think they'll be able to do it in about an hour and a half to 2 hours. When they're done, the 2 astronauts are going to get up on the robot arm, ride up to the top of the space telescope up here for the second time. You'll remember they replaced some magnetometers up here night before last. And while they were up there, they found that the old magnetometers were leaking. It could be leaking insulation. So a couple of the astronauts took some insulation material, gold leaf foil, and made little hats. The little hats are going to go up on top of the old magnetometers. They'll be taped in place to prevent that material that's in there from leaking out.
And that's the job everybody wants, because that's the best view of the mission.
Right, it's perfect view. Susan, I'll be here all night long, and our viewers, if they'll stay tuned, will see some dramatic pictures.
Oh, some beautiful pictures. We've really been spoiled this week. Thanks, John.
Sure.
We'll see you later.
Michael is my brother. I love him a great deal, but I cannot and I will not be a silent collaborator of his crimes against small, innocent children.
Michael Jackson's sister speaks out about the pop star's alleged crimes. And U.S. astronauts step out of their space shuttle a 5th time to fix the Hubble telescope. And joining us now live here once again is CNN's John Holliman to talk about the U.S. Space Shuttle mission to repair the Hubble Space Telescope. And John, we've just heard that there's apparently a small problem.
Well, you know, this is a very complex piece of equipment, Bettina. The problem that they're working on right now, I think you can see it live. That's the Space Telescope as seen from the cargo bay. And if you look on either side of the telescope, there are tubes attached to the side. Those tubes are the solar panel cassettes. The new solar panels that will be used to power the telescope are rolled up inside those cassettes. And about 15 minutes ago, ground controllers at the Goddard Space Flight Center in Maryland gave a command to those solar panels to unlatch from the top connection point at the telescope, and then to move out perpendicular to the telescope. They unlatched properly, but they didn't move out the way they were supposed to. You can see now the shuttle's robot arm coming across the center of our screen as it goes down to pick up astronaut Story Musgrave. At this point, controllers have not figured out what to do about this problem. What they're going to try to do is, there's a motor down at the bottom of each of the solar panels, and that motor, there's a spare motor, so two motors could actually be used to drive those cassettes down into the proper position for the final deployment a little bit later on. They're going to try to use both motors together, and if that works, then you'll see those panels begin to float down into a position perpendicular to the telescope, and a little bit later on in this spacewalk tonight, the panels will begin to unroll. Astronaut Story Musgrave, Jeff Hoffman, both out in the cargo bay now. They're just beginning their night of spacewalking activity. They have a couple of new things to add to their list of problems to solve. There's one with the new computer added to the telescope's old computer last night. And the astronauts are in the cargo bay discussing what to do about this and the other problems with the controllers on the ground right now.
So this mission might take longer than they had expected?
There's a possibility that the astronauts might have to go back out into the cargo bay again tomorrow night. Not necessarily for the problem with the solar arrays, because it can be solved fairly quickly by an astronaut out at the end of the robot arm, just manhandling that cassette and forcing it down into the proper position. But if the main computer aboard the Space Telescope has to be replaced, turns out the astronauts, without telling anybody, brought a spare, entire new computer. We had no idea until about 3 hours ago that they had brought one along. And they might take out the entire old computer, replace it with a brand new one, which would solve a lot of the problems that the ground controllers have had in getting pictures back from the telescope in the past. But that would take an extra spacewalk to do, because it would take several hours to get the old computer out and the new computer installed. So we'll be back, of course, throughout the next 6 hours of this spacewalk with our continuing coverage of the mission on Project Hubble.
Thank you, and we'll speaking to you later then.
Good.
Hello and welcome back to our special coverage of the spacewalk, the fifth spacewalk of U.S. Shuttle Endeavour astronauts. And they're trying once again to repair the Hubble Space Telescope, and you're watching right now live pictures. In the last few hours, NASA had to encounter a few problems. And one of the problems is that they had problems with the computer. One coprocessor, which they installed last night, didn't send the right signal, so they have to fix something on that. And then also they have problems with the solar panels that were installed at the beginning of the week. And that's the job that the two shuttle astronauts are doing at the moment. It's Story Musgrave and Jeff Hoffman. Why don't we join and listen?
That's a negative, Covey.
Okay. D7. Tom, I have the D-mate ready for Story when he needs it. Okay. I'm going to go take a look at how the pins, how the screws are. Are you going to start those manual ratchet door? I am, yes.
The problem that NASA has now with these new solar arrays is when ground controllers send a signal to drop the solar array cassettes into place perpendicular to the telescope, nothing happened. The drive motors that were supposed to move the arrays did not work. And so the astronauts believe those might be jammed and additional motors might be necessary to help move them into place. And joining me now once again is CNN's John Holliman.
Tina, it's very interesting. I've just been on the phone with some officials of NASA to try to get a last-minute update on what is going on and what will be going on. And they have some fairly good news to report. What we're seeing right now, of course, astronauts Jeff Hoffman on the top of your screen and Story Musgrave out at the end of the robot arm, they are replacing a black box which controls one of the solar array panels on board the Space Telescope. That's the first of their scheduled duties for the night. There are two other problems that we have been talking about. One that you were just mentioning with the solar arrays. The ground controllers say they believe they're going to be able to make those solar arrays come down as soon as the sun has been shining on them for a period of maybe a half hour. They think that just having the sunlight and the heat, which is about 200 degrees above zero, hit those solar panels for 10 or 15 minutes will loosen them and allow the drive motors to bring them into place. Also, the computer problem that we have been talking about, the coprocessor is what NASA calls it. It's a panel with some additional memory chips for the Space Telescope's only onboard computer, is also believed to be a problem that may not be a problem with the computer, but rather a problem with the radio transmission from the Space Telescope to the ground. Normally, the telescope has two antennas attached to the telescope, which are used to send telemetry, computer information from space to the ground. Those antennas are not being used while the telescope is there in the cargo bay of the shuttle. The shuttle's antennas are being used. And about 4 hours ago, when they tested the computer the first time and found that it was not working properly, it was sending information, but the information was just slightly garbled. And the garble might have been caused because it wasn't using the telescope's own antenna. It was having to go from the telescope to the shuttle, from the shuttle to a relay satellite, and from that relay satellite to the ground. So the NASA managers at the Goddard Space Flight Center in Maryland believe that the astronauts may not have to do anything to solve this computer problem. They'll raise the telescope's own antennas during the process of this spacewalk, turn them on, and see if the computer works perfectly when its own antennas are in place. So the news that I was getting from the Johnson Space Flight Center in Houston just now was very good news. They have been watching our coverage and suggested that we shouldn't worry our viewers too much, that they may have this well under control. We'll see.
Yeah, they don't want any public relations disasters here.
Exactly.
On the fifth spacewalk.
I'm sure that's exactly why I got the phone call that I got. But NASA is very public relations conscious, certainly, because this telescope, as you know, was touted so highly as being the best thing in the universe for taking pictures of the universe, and then we discovered it was out of focus. Over the past 5 nights, the astronauts have replaced all the optical systems in an effort to correct for the out-of-focus main mirror. They've replaced the gyroscopes that keep it steady. They've replaced the solar panels that will power it. And the astronauts now replacing the electronics drive package that makes the solar arrays shift toward the sun during the various times that the telescope is operating. I was just talking to an astronomer who uses the Space Telescope, and he says the replacement of this drive electronics box is going to be very important because in the past, the telescope has not been able to turn itself to all the objects in space that it wanted to look at all of the time because there was some worry that there are 2 of these boxes, the drive electronics boxes, but with one of them broken and the backup being used, if the telescope had been pointed at a distant object that was far out of range for the solar panels and the second box were to go bad, the telescope would get to a point where it could no longer see the sun, the batteries would go dead, and there would be a $1.6 billion piece of space junk up there rather than this space telescope. So, what's going on right now, Musgrave and Hoffman have loosened some electrical connections on the side of this solar array electronics drive unit. The NASA acronym for this is SADE. It's for Solar Array Drive Electronics, SADE. And
you got to be really careful how many turns.
Absolutely.
And probably we should be pulling out on the connector while you do the last few turns, you know. You got to hold it in. You want me to hold? Is that last one in enough, or has it started out? No, see. It's okay, it's okay. They're both in good shape. All right. I held in the whole time. Okay, P7 is out. Good job. All right, P8. Okay, we experimented. We know what we're doing. Great technique. Found out what we got. Better optimize my light here for you, Troy.
Bettina, this job is taking so long because there are 3 or 4 computer connectors on the side of these electronics boxes, and these things are not designed to be worked on by astronauts wearing very thick spacesuits. The connectors are similar to the connectors that our viewers would have on their home computers that connect the computer to the printer, and they have tiny screws screwing those connectors into place on the side. And for an astronaut using a normal screwdriver, well, he couldn't use a normal screwdriver because of the size of those gloves. And so they're being very, very careful as they turn these small, delicate screws using instruments specially designed just to do this job. And they're doing it very slowly. They don't want to damage the pins inside those connectors and want to make sure when they plug the new replacement solar array drive unit in, it works.
And we'll be back with more of our live coverage after a short break. Stay with us. Welcome back to our special live coverage of this special mission in space. What's going on at the moment, John?
Right now, 2 astronauts are out in the cargo bay next to the Hubble Space Telescope. They've opened the door in the side, and we can tell you that they are about to replace a solar array drive electronics box. Let's listen to the NASA commentator for a moment.
In excellent shape, and the results could be that there had never been a problem at all with equipment on board. But again, it's not confirmed, and they're still analyzing the nature of that problem. An analysis that's likely to continue throughout the night tonight.
That was NASA commentator James Hartsfield telling the NASA television viewers what you and I were just talking about, Bettina, about the computer problem. It may not be such a big problem after all. The astronauts now, though, are working on a drive electronics unit for the Space Telescope's, one of the 2 drive units for the solar panels. And we have an arrow that we can use to point to the replacement solar array drive electronics unit. There it is. It's a black box that you see at the tip of that arrow point that's just dangling by an equipment cord now. And in just a few minutes, the astronauts will have completed disconnecting all the computer cables from this box. And the box itself will then be unscrewed from the door panel where it's located. The new box will be first screwed into place. And then the electronics cables will be hooked up on the side of it. When all that's done, and it should be done sometime in the next 45 minutes, it'll be tested by ground controllers and will be used eventually when the solar panels are fully extended to keep those panels pointed toward the sun. I was talking to a space telescope scientist a few minutes ago who said that this is very, very important. The solar arrays, have to come away from the side of the space shuttle, and when they were ordered to do that by the ground about an hour ago, they refused. And it's hoped and expected by ground controllers that after the solar arrays get heated up, when the shuttle next comes into sunlight, that they'll come loose from the stuck position where they are, and they'll just fold down to their proper position. And after that, the solar array, then they'll be extended. They'll unfurl, sort of like pulling down a window shade.
This view showing the replacements tethered to the work platform at the end of the arm, while on the door are the boxes to be replaced for the drive electronics. Again, these electronics operate the solar arrays as they unfurl.
By the way, Bettina, about 2 hours ago, we were watching from the ground as the Hubble Space Telescope was tilted forward in the cargo bay. One of the things that the ground-based managers wanted to do, if possible, was to raise the altitude of the Space Telescope about 6 or 7 miles. If they could get it 6 or 7 miles higher than where it is right now, they figured they won't be worried about it coming low enough in orbit to crash back into the Earth between now and the next time they send a shuttle up to do that. It's never been done before. They tilted it forward in the cargo bay so that it was not all the way down, but down at about a 75-degree angle. And then they fired the rockets on Endeavour, and something unusual happened. The telescope, the Endeavour, did go up in the air. The Space Telescope began to oscillate. It moved back and forth in the cargo bay. We have some pictures we'll show you later in the next hour or two to illustrate this, but the Space Shuttle commander, as he looked at this, said this is a very unusual thing, and the ground-based people had not expected the telescope to oscillate in that way. Astronomers are now wondering if anything came loose during that oscillation phase of the Space Telescope. Every time it moves, of course, they cross their fingers and become a little bit nervous. So,
when will the Hubble telescope be released from the shuttle? When is it all done?
About 24 hours from right now. it'll, if everything goes well tonight, if they don't have to do a 6th spacewalk. One of a NASA manager who I spoke to on the phone before I came over a few minutes ago said, don't expect a 6th night of spacewalk. They are virtually certain, and they'll be announcing this in the next 30 or 40 minutes, that they won't have to do a 6th spacewalk, that when they finish tonight, they'll be finished.
Is there any idea why we at the moment do not get pictures?
Yeah, the space shuttle itself travels through space, and there are a couple of fixed communication satellites that it has to use to send picture back down to Earth. When it's the radio communication for voice communication works 24 hours a day, so you can always talk to the astronauts, but there are times when you can't see them, and there are periods, times between the two satellites that sometimes last 3 to 4 minutes and sometimes last up to 10 minutes. We may be into one of those 10-minute olds now because I think 3 to 4 minutes has gone by when our viewers have been forced to look at this face rather than the beautiful pictures from the astronauts in their spacesuits.
What are the astronauts going to do if they don't go out in space anymore for the rest of the mission, the next few days that they will still spend in space?
They're going to have a lovely time, Bettina. This mission was designed to give them extra days for extra spacewalks, and every astronaut that I've ever spoken with says, what we really like to do is spend time looking out the window, looking at planet Earth from the space shuttle without people talking to us and forcing us to do job A or job B, and that's what they're going to do. The job 24 hours from now will be to release the telescope. Then there's some housekeeping things they have to do aboard the shuttle to get ready to come home. The landing is scheduled United States time, 3 o'clock in the morning on Monday. So they will have from now until, or from the time the telescope's released, 24 hours from now, until 3 o'clock in the morning.
Which will be 0800 GMT on Monday.
Yeah, to look out the window and admire the Earth from above. They have some exotic photographic equipment. They have some really nice cameras. They'll be taking pictures from up there of us down here, and they should have a very good time of that.
But they don't do any experiments or anything?
No,
not just like the last time when they took 48 rats along.
Right, no rats, no laboratory rats, and no guillotines in space. The astronauts have been, by the way, very physically healthy. They, for the past 2 missions, astronauts have not been subject to space sickness, this awful thing that has always happened to Americans the first day that they go in space, where they just get sick to their stomach and awful headaches. The NASA medical team has been working very, very hard to give them medicines or exercises to do to prevent this space sickness, which makes their first 5 to 6 hours in space awful, and it seems to have worked for the past 2 crews. So they won't tell us, they haven't yet told us precisely what they're doing, but whatever it is seems to be working.
How is the daily life on the shuttle?
They get up at about 7 to 8 o'clock at night Eastern time. The GMT for that would be what?
7 or 8 would be like 2400.
Yeah, 2400 GMT roughly. That's when they get up, which is much different from when they get up in the United States. They have about an hour to do what you and I do when we get up, and there's no television coverage, and they leave them alone for the first hour.
Except for the rock music they play every morning.
Right. Geez, there was Claude Nicollier selected the wake-up call music today, and it was some unusual, to me at least, accordion music. I don't know what the piece was, and it didn't sound like the American rock and roll that you normally hear from the shuttle, but that's because we have an international astronaut, a man from Switzerland, who's operating the robot arm as the astronauts do their work in space right now. And anyway, after they get up and do the first hour's business, they have a briefing with the NASA managers on the ground. What's different? What's changed? They can communicate with their families. They have a fax machine that they can send letters back and forth. I have, perhaps later in the morning, I'll bring you some of the faxes that the Hubble Space Telescope scientists have been sending back and forth to the astronauts. They're very funny. Some of these faxes, there was one that showed a check to the astronauts for $1.5 billion signed by Edwin Hubble. And we've got live pictures? No, we've got pictures that were recorded earlier from space. And anyway, this fax was a check for $1.5 billion, and the astronauts sent back a very funny fax with insufficient funds on the front of the check, and so they have time to communicate that way.
Yeah, one of the husband of Kathy Thornton, the one woman here on the shuttle mission who has been doing 2 spacewalks, the first woman who has done 2 spacewalks, he apparently was totally enchanted with whenever he saw her and said, I just wanted to grab her. I wonder how that went along.
I wonder. Well, Thornton, when she's been out there on the robot arm, has been grabbing her partner, Tom Akers, in order to get him into some of these nooks and crannies aboard the Space Telescope that have been difficult for the astronauts to get to do these various jobs.
Their leading culprit at this point that they are looking towards, again, the shuttle, as it moves through its various attitudes, has differing locks of communications with the tracking satellites overhead. And controllers have had a couple of orbits that Mission Control arranged to provide excellent communications with the satellites. During that time period, they dumped several computer memory dumps and saw those very clean and well received on the ground. Thus, they are checking out communications as a possible problem, which could leave the equipment on board in excellent shape, and the results could be that there had never been a problem at all with equipment on board.
This is NASA commentator
again,
James
it's not
Hartsfield
confirmed.
reported earlier as he explained what we were just talking about with the computer. It's good news if this computer that they attached last night is in fact okay, and they'll know for sure once they raise the antennas on the side of the telescope and let it talk directly to the Earth. The astronauts are now a little over an hour into their 5th spacewalk. They plan to be out as much as 6 hours, but they may get all this work done earlier than expected, particularly if the computer problem turns out to be a non-problem.
Which is what they're really hoping for, because that would be just horrible. If they install a new component and then the next night they suddenly find out, whoops, this thing didn't work.
Exactly. There were other things that they had planned to do. They could have taken a computer plug from one side of the new computer, plugged it into the other side to see if that solved the problem. And it was an elaborate thing because it would have to be choreographed. It would add an hour to an hour and a half to their time in space. And as long as they are out there, as our viewers, I think, understand pretty well, they are in a little bit more danger than they are in when they're in the safety of being inside that metal space shuttle compartment. They're vulnerable to being hit by a micrometeoroid. They're vulnerable to snagging the suits on some of their equipment, possibly. And so NASA managers want to stay in very close touch with them the whole time they're outside.
Forward. That's for me.
Now, if you look on the right side of your screen, you can see the location of the old solar array drive electronics box. Story Musgrave is stretching out his right hand now, almost to where that drive electronics box is located. The old box is coming out now. The new box will be installed in the course of the next 20 or 30 minutes. And it looks like this part of the mission, at least, is going very, very well.
Good. Thank you very much, John, for again joining us, and we'll be back with more in a little while. Thank you.
I'm going to get off here so that I don't shake you. Doing fine, Jeff.
There you have live pictures from the Space Shuttle Endeavour, where U.S. astronauts are on a 5th spacewalk to repair the Hubble Space Telescope. Jeff Hoffman and Story Musgrave are working on the electronics in the telescope's solar power system. They may also work on a problem that cropped up in computer equipment installed during the previous spacewalk Wednesday. That problem could force the crew to make a 6th spacewalk Friday. This current walk, the crew's 5th, sets a record for the most spacewalks by an American crew in one mission. NASA controllers found a potential problem with the computer coprocessor, which the Endeavour spacewalkers installed piggyback style over the old onboard computer.
I think I'll take your hand, Jeff.
And in addition to the computer problems with Hubble's onboard computer, there are additional problems with the new solar arrays. Apparently, when ground controllers sent a signal to drop the solar array cassettes into place perpendicular to the telescope, nothing happened. Apparently, drive motors that were supposed to move the arrays didn't work. It's thought they may be jammed, and additional motors will be used to help move them into place. Astronauts Story Musgrave and Jeff Hoffman now working on the Hubble Space Telescope.
Easy.
The impact of this so-called computer glitch has somewhat changed the order of the tasks on the mission tonight. And it meant that some of the tasks, which were not all dependent on the computer, had to be accomplished first. Now, if the installation of a new onboard computer is required on Hubble, NASA says that would likely require a 6th spacewalk.
The bag, I got it in my hand again. Copy.
We now rejoin live satellite pictures from Endeavour, where astronauts Story Musgrave and Jeff Hoffman are in the middle of their 5th spacewalk. Let's listen into the description from Mission Control.
That screw was a priority, but if it had gotten away, it was something that is part of the business of being in space.
Down 6, please, climb. Down 6. Now that I know them kind of feel for, I'll go get the lower ones first. Yeah, I'll hold them in. I'll hold the box in. Okay. Little further climb. Stop, please. Stop.
The two astronauts are working on drive motors that were supposed to move the solar arrays on the Hubble Space Telescope.
Go ahead, Tom.
Yeah, Greg, can you copy how Story's going to do P1 that he didn't have access?
It's thought that the original drive motors might have jammed, and additional motors might be used to help move them into place.
Hello, I'm Andrea Arsenault at the CNN Center in Atlanta. Here's CNN's John Holliman with the latest on the Hubble repair mission. John?
Andrea, two astronauts are out in the cargo bay of Shuttle Endeavour right now. You can see them on your right, Story Musgrave, on your left, Jeff Hoffman. What they're trying to do is replace a solar array drive electronics unit, which you can see to the right of Musgrave, who, as I say, is on the right of your screen. It's the box with the white line around it, the rectangular line. That box has now been disconnected from the door where it's been mounted for the 3.5 years of the Hubble Space Telescope's life so far. And there are 8 computer-type connectors connecting that box to various parts of the telescope, and 7 of those connectors have been disconnected effectively. The 8th one was stubborn, would not come off, and so the astronauts decided to pull the box off the door, loosening bolts that hold it onto the door so that it will float free out in space, and they think that by doing that they'll be able to get this 8th connector off effectively. Because they've had the problem with the connector, the mission is taking a little bit longer. This part of the mission is taking longer than had been anticipated. The replacement unit, the replacement solar array drive electronics box, can be seen floating in space between the two astronauts. You can see the black box and the white band around it, which is facing down now in virtually the center of your screen. Why don't we listen as the astronauts talk about the success they're having, or the lack of success they're having, in replacing this box. Another view from the robot arm camera on board Endeavour. As you can see, the open door there in the side of the Space Telescope.
The bag, and I caught that too. All right. We're getting my practice here. To the right now, Claude. Okay, to the right.
You're going to move the robot arm slightly. About 15 minutes ago, one of the astronauts dropped a screw out of one of these computer connectors. The screw, smaller than your little fingernail, fell down toward the cargo bay. Despite the fact there's no gravity, that's the way the screw was moving. The astronauts on the robot arm were pushed themselves down to where that screw was and grabbed it in midair and brought it back up.
Correction for Tom.
Go ahead, Greg.
Tom, just curious, we've been watching Story and Jeff out there and haven't got a camera view of the PDMs. We're wondering if there is any observed change in position of either of them.
That's astronaut Greg Harbaugh talking to astronaut Tom Akers inside.
And it is still fully seated in the aft latch. The plus V2 doesn't appear to have moved. We don't have as good a view of it, but the minus V2 is still fully seated. And one of the things we were thinking about is, we left both of those microswitch guards in the change-out position. On plus V2, it's because we couldn't pull the pit pin through the plastic. And on minus V2, it's because after the aft latch was closed, it was caught in there, it wouldn't slide. So we were wondering if maybe that's giving you a little bit of friction.
Kathy Thornton talking
Well,
about
that's
another
exactly what
problem
we're
that the
thinking.
astronauts are dealing with, or maybe dealing with later tonight. The solar array panels, the solar panels that will provide power for the telescope, are supposed to, were ordered by the ground, to unfold from the side of the Space Telescope and come down in a position perpendicular to it. And those solar arrays are, of course, very necessary. Greg Harbaugh now talking to Kathy Thornton about what she did when she installed the solar arrays a couple of nights ago.
Okay, we're kind of hoping the same thing.
Harbaugh was just saying that as the space shuttle and those solar panels get out into the sunlight, which you see being reflected back from Earth, perhaps the heat from the Earth will warm the panels up to the point that they will spring loose from the things that are holding them to the side of the telescope.
A discussion by Kathy Thornton relating to the solar arrays on the telescope. The PDMs are the primary deploy mechanisms, which basically fold the arrays down away from the body of the telescope. The current thinking is there may be a small interference with the microswitch guards that basically provide the indications that the solar arrays are in the proper latched position. And so the discussion that's ongoing relates to possibly having the crew members go up to the top of those solar arrays and give them a slight nudge to free them from the latch mechanisms. The latch mechanisms have already been released and confirmed in the open position.
Michael Sherrill, we've been talking about the solar array drive electronics and how important it is to have a good electronics box to steer the solar arrays toward the sun. But those solar arrays in the position where they are right now are pretty worthless to those of you astronomers on the ground who look at the pictures coming back from the Hubble Space Telescope, huh?
We certainly have to have the solar panels extended. There's absolutely nothing that we can do until that successfully happens. The 5 kilowatts that those panels generate are the only power source on board the Space Telescope. We could never, of course, have put a little nuclear reactor on board. The waste radiation would have done all sorts of damage to the instruments and given us false signals. So there was no choice but to use solar panels. When they work, they're just wonderful, but getting them to work is obviously not going to be the easiest thing going on tonight. The SADE electronics box that points the solar panels at the sun, too, is just essential to us. We've got to have that working. Otherwise, if it's not, we are very, very restricted. With only one SADE in place, there's only a modest section of the sky that we can point at any one time. The reason is health and safety of the telescope. When one SADE is working, one solar array deploy electronics box is working, there's always the danger that it'll fail at any one point during the mission. And then we would have no way of getting the solar panels pointed back at the sun in time to prevent all sorts of damage to the instruments on board the telescope.
All right, while we're away from our live picture from space, we're going to take a quick break. We'll be right back in a couple of minutes with more on the mission of Space Shuttle Endeavour to fix the Hubble Space Telescope. Stay with CNN. Welcome back to CNN's live continuing coverage of the mission of Space Shuttle Endeavour to repair the Hubble Space Telescope. This is the 5th night of spacewalk for the astronauts. Story Musgrave, Jeff Hoffman out in the cargo bay of Endeavour right now, working on a solar array drive electronics box which tells the solar panels on board the Space Telescope where to point to find the sun. When that job is done, the astronauts are going to get on the robot arm and go all the way to the top of the telescope for the 2nd time on this mission. They'll go up there. Last night, astronauts fashioned some little caps made out of gold leaf material that will fit down on top of the old magnetometers, which the astronauts have replaced with newer versions. The old one's still out there, and there's some concern that the old magnetometers might leak insulation, which could get down into the barrel of the Space Telescope. Not a good thing, so there's a protective cover that the astronauts fabricated out of some leftover material, which will be installed in the next phase of this mission tonight. And when that is all done, the astronauts will continue their efforts at checking out a computer on board Endeavour, which they think is probably not damaged at all. The solar array problem, which we've been talking about, might be solved by the astronauts or might be solved by using the drive motors that are already there to extend the solar arrays. But the astronauts will be prepared and will probably be in the neighborhood to help out from the time that those solar arrays are lowered from the sides of the telescope till they're unfurled and generating electricity. Because I'm sure the astronauts don't want to have the space telescope go away from the space shuttle without knowledge about whether those solar arrays are going to be generating electricity. It'll be very important to have that electricity or the telescope will become worthless. Uncle Shara, we've talked throughout this mission about the fact that some critics have said the Hubble Space Telescope couldn't see straight and couldn't do very much about providing pictures to astronomers on the ground. You're one of the astronomers who uses this telescope every day. Are those critics right or wrong?
They're absolutely wrong. The telescope has been doing exquisite science almost from the day that it was launched. It's not as good, it's not as powerful, it hasn't been seeing as clearly as was originally designed. That, of course, is one of the reasons for this mission, though this mission was also planned to do various other upgrades to the telescope. The best way I can prove that to you is by showing you, as I did yesterday and I'm going to tonight, show you some graphics, show you some images, actual images that have been taken by the Space Telescope of various objects that the Space Telescope looks at, and tell you something about the scientific discoveries that have been made with the Space Telescope in the past 3.5 years. And if we can look at that first graphic, please. What this is an image of an object that's called a planetary nebula. The name of this thing is Henize 1357, from the ground it's basically just a fuzzy little blob. You can't really see any detail. What is clearly visible in this picture from the Space Telescope is, first of all, that ring that's tipped at about 45 degrees. It runs from the lower right to the upper left.
Sort of an oval-shaped yellow ring in our picture here.
Exactly right. And that ring is telling us something very fundamental about the central star. You can see a bright dot near the center of the image, and that's the star that gave rise to this planetary nebula. Now, a planetary nebula is almost certainly the death of a star. We're seeing a star just in its death throes. The star has run out of its fuel, which is hydrogen in the core of the star, and as the central part of the star contracts, the outer part of the star is expelled, and that's the shell of material that we see moving away from that central object. The ring, on the other hand, is almost certainly the signature of a binary star. It's probably not a single star that has ejected the mass, but rather one of two stars in a binary at the center. And it may well be that the orbital plane of the two stars is in the plane of that ring. And that's probably what gives rise to that ring. We think that a good fraction of all the stars in the Milky Way, and probably everywhere in the universe, are binaries. And this is one of the clearest ways of seeing that binary signature.
It's remarkable, and from the ground you can see virtually nothing of this.
There's just a fuzzy little blob. With the Space Telescope, you can really see it in tremendous detail. There are only a few planetary nebulas that are close enough to us that they can be clearly resolved from the ground. With Space Telescope, almost every planetary nebula known in the galaxy, and even planetary nebulae in nearby galaxies, can be resolved, and we can see the details in their ejected shells.
Right now, live from space, we're watching astronaut Story Musgrave, who's on the bottom of your screen, with his partner Jeff Hoffman, whose hand is holding the solar array drive electronics box up at the top of your screen. Can't tell at this moment whether the astronauts have managed to disconnect that 8th electrical computer connector from the side of that box to get it out of the way so that it can be brought back and replaced by the new box, which the astronauts are also have in their hands there. But the replacement mission seems to be going pretty well. There are 8 computer-type connectors on the side of that box. The astronauts, even in their spacesuits, were able to use screwdrivers to remove 7 of the 8 connectors successfully, the 8th one creating some problem for them. Why don't we listen in and, as the astronauts talk for a minute to see what their estimate is of the progress they're able to make.
Go like this.
That was Story Musgrave's voice. With the box attached to the door of the telescope, they were having difficulty getting that last connector to come off. And so they decided to remove the box so that it would be pulled out from the door in hopes that would give them a little more room to maneuver.
Hold on just a minute. Let me get my visor down. It's going to be in my eyes. All right.
sun's coming out. You can see Jeff Hoffman pulling his visor down to prevent radiation from damaging his eyes.
It's
and to act as
remarkable.
sunglasses.
It's remarkable just how bright the sun really is. You can see the amazing reflections coming off the leg of the astronaut at the top, and points out just how difficult it can be to work if you don't have a good pair of sunglasses on up there.
Exactly. Now, are those visors optical instruments?
They're of optical quality. The astronauts have to be able to see perfectly, and they have gold coatings over them, real gold, in order to block the ultraviolet radiation from the sun.
So that acts as their ozone layer.
That's exactly right.
All right, you see Story Musgrave continuing to work in the box. Let's listen again and see if we can tell whether the final connectors come off or not.
And I can hold it away and point it at you with this. No, we'll do the minimum. Okay, minimum amount. So to remember how to stress on the wires. Yeah.
From time to time in our picture, you'll see this orange thing that looks like a glove, actually sort of like the kind of glove you might wear to clean your kitchen sink, that is attached to the astronauts' spacesuits. It's a specially designed glove only worn by astronauts who do spacewalks, and the purpose of it is to give them a little extra protection in case their hands begin to get cold. Story Musgrave has been involved in the spacewalk training program for NASA for years and years. This mission he's been training for more than a year. And one of the tests was, when astronauts are working, when the sun is not reflecting on them, as it is right now, how cold might it get on their spacesuits, and what might that do to their bodies? And Story Musgrave, in fact, had 4 fingers that got a slight case of frostbite because the conditions in a test chamber at NASA was so cold that his fingers were actually harmed by the cold. One result of that, the astronauts now carry an extra pair of gloves that will go on over their spacesuit gloves, just in case their fingers get colder than they are comfortable with. Story Musgrave says that so far on this mission, there's been no problem with temperature at all. If anything, the spacesuits have gotten a little warm, not cold. And the system on the spacesuit that acts as air conditioning only cools. It's not necessary to provide heat to the astronauts' bodies, even though when they're in darkness, it's 200 degrees below zero, because their body heat is kept inside by the insulation on the spacesuits.
Internal demate tool. All right. Move you away from the door, please, Claude. I'll trade you tools here.
In addition to the 2 astronauts out in space here, Claude Nicollier, the Swiss astronaut, is operating the robot arm. Story Musgrave's talking to him about moving the arm a fraction of an inch right now to make it easier to remove this black box from the door. Another view of this. You see Hoffman hanging out over planet Earth there. What a picture. The camera was just tilted up so that you could see one of the solar arrays. Actually, you can see one of them completely, the other one partially on the right of the telescope. Ground controllers ordered both solar arrays to extend 90 degrees from the position where they are right now so that they would be sticking out like arms on the side of the telescope, and they didn't do it. And it's hoped by ground controllers that the fact that the solar panels are in the sun right now will warm them, heat them to a point that when the next set of commands to extend come, that they will actually move out.
You can bet that all astronomers are going to be rooting for those commands. The panels absolutely must extend, and this is a bit of a nervous minute at this point.
Sure. Now, the astronauts can crank them out manually, Michael, if they don't follow the command. Would you, as an astronomer, be worried about the human touch versus the electronic and electric motor touch to get those panels out in the proper position?
Well, I'd certainly rather have the panels properly deploy in the nominal way. That would just be very nice, very smooth. But the astronauts have practiced extensively all sorts of contingencies, including this one. They know exactly where to touch and where not to touch. And if it takes muscle power, human power, so be it.
Well, the mission, after 4 nights of virtually perfect spacewalking. I suppose it's almost inevitable that the astronauts would be faced with a few problems at least one of the times that they're out there in space. And it appears that that's exactly what's happening. This appears to be glitch night for the Hubble Space Telescope repair mission. Compared to the other things that have been done, how critical is the work that they're doing right now?
Well, certainly the solar deploy electronics are important. We could continue to function with one. We'd much rather not. Because there are several thousand targets scattered across the sky, we can continue operating the telescope and not lose any time on the telescope, even if we only have one SATI box working properly. If we have two, then we have a lot more redundancy, a lot more safety, and it also makes the life of the schedulers much easier, and we can schedule the telescope slightly more efficiently. The deployment of the solar panels, on the other hand, is absolutely 100% critical. That must work, otherwise we don't have power for the telescope and we just can't do anything.
Michael, NASA explained what they think the problem was when they turned on the new coprocessor for the telescope's computer. What was that problem, and how does it sound to you? Does it sound like something that might be easily fixable?
Well, the problem may be almost a non-problem if the earlier reports were correct. The suspicion now is that the communications between the telescope and the shuttle are not working properly. There's perhaps a bit of an antenna problem, and as a result, when we're trying to send commands or receive data from that coprocessor and from the computer on the telescope, it's basically a communications link problem. And so there's a rather easy workaround, and that's simply to dump the whole memory directly from the computer, from the DF-224 computer, all the way down to the ground via the TDRSS satellite, and simply bypass the shuttle altogether. If that test works, then we know that the coprocessor problem isn't a real problem, and we can simply forget about it. When the telescope is released, we'll be able to communicate directly with it.
Now, the telescope has its own antennas, of course. Do those antennas communicate right to the ground, or do they go through this tracking and data relay satellite?
All of the communication with the Space Telescope is done via the TDRSS satellite. The TDRSSs then send information down to the ground, often via other relay satellites. We don't communicate with Space Telescope directly from the ground.
All right, and at this point, I guess those antennas, which are also folded up against the side of the telescope, are not doing the communicating, right? There's another communications path that's used besides those antennas.
That's correct. Those antennas send data at a much higher rate, basically a megabit per second. Right now, we're limited to the much lower data rates, but that's certainly sufficient to get a memory dump from the DF-224 and make sure that everything is okay.
The DF-224 being the Space Telescope's main computer, and only computer.
That's correct.
To bring you up to speed on what's happening in space right now, two astronauts, Story Musgrave and Jeff Hoffman, are in the process of removing a black box from inside one of the doors of the Space Telescope. The black box is a spare device which would point the solar arrays on the telescope toward the sun. They have to be pointed at the sun as often as the sun is around in order to keep the batteries charged, in order to keep electricity flowing through the telescope to let it do its job. One of the two boxes there is working fine, and one of the boxes is not working at all, so the one that's not working is being removed by the astronauts. They're having some trouble getting it removed. Not the box itself. They have already unscrewed it from the door panel where it's stored, but there are 8 computer-type cables that attach that box. I'll show you what these cables look like. If you have a home computer, you're very familiar with them. They look just like this. 7 of the 8 came off easily. The 8th one had a big problem. The astronauts were attempting to remove these very tiny screws. They're pretty easy to remove on Earth with a small screwdriver. In space, though, the gloves that the astronauts wear are big and bulky. They've had some trouble getting those screws to turn so that they can unplug the final plug and pull out that box for the installation of the new one. We're going to take a break now. When we come back, we'll bring you right back up to date as to what the astronauts are doing and how they're accomplishing their missions for the night. Stay with CNN.
And welcome to our live coverage of the 5th spacewalk of astronauts aboard the Space Shuttle Endeavour. We now join CNN for the latest on the mission to repair the Hubble Space Telescope.
I catch up to the telescope by moving slightly faster.
All right, we're welcoming our CNN International viewers to our viewer call-in portion of our program. The pictures you international viewers are seeing right now are pictures recorded just a few moments ago from the side of the Hubble Space Telescope as astronauts continue their work of trying to replace an electronic black box on the telescope, which is used to steer the solar panel so that they're always pointed toward the sun when the sun is available. Our next caller is from Florida. Go ahead. You're on CNN.
Hi, good evening.
Hi.
I have a question about how the Hubble can supposedly look back in time. I understand that when an event happens in deep space, and we see it on Earth, this event actually happened a long time ago, and we're just seeing it due to the amount of time it takes the light to reach us on Earth. But the telescope can actually see those events long before we see them. And I'd like you to explain to me technically how they're looking back in time like that, since the light takes basically the same amount of time to reach a telescope as it does to reach us on Earth.
Sure, I can certainly address that question. When we look out at a distant galaxy, what we're seeing is the galaxy as it was millions or even billions of years ago. Depends, of course, on how far away it is. And it's also worth remembering that when you're standing next to a friend, you're not seeing your friend instantaneously. It does take some tiny fraction of a second for the light bouncing off your friend to reach your eyes and to register in your brain. Well, the same thing is happening with the telescope. The Hubble telescope looks out at a galaxy that's, say, 10 million light years away. Well, it's taken the light 10 million years to get to the telescope from that galaxy. And so we're seeing that galaxy as it was 10 million years ago. If the galaxy were to suddenly vanish, or if a supernova were to blow up in that galaxy, it would take 10 million years for the light to get here. A lot of the light that's coming from galaxies, say, 100 million light years away, was emitted by those galaxies or by the stars in those galaxies when there were still dinosaurs on the Earth.
Amazing. Thanks for your call and thanks for your answer, Michael. Our next caller is from Massachusetts. Go ahead. You're on CNN.
All right. My question is, where did NASA get the funding for the telescope? And was it tax money? And how long till the telescope pays for itself?
It is tax money, and you and I certainly did pay for it as part of the NASA overall budget, at least much of it. Some of the money to build it came from the European Space Agency, which has contributed the solar panels, has contributed the faint object camera, and some other equipment on board the telescope, as well as some scientists to it. Michael, the other part of the question might be to you.
Well, it is an interesting bit of trivia to note that it was Gerald Ford who was president when the telescope was approved. That's how long ago it happened. When will the telescope pay for itself? Well, in some sense, it's paying for itself now by providing us with some of the beautiful images that I've been able to show you last night, and I'll show you some more of them shortly. It's not going to be a money maker in the sense of returning billions of dollars in cash or tangible goods into our pockets, but what it returns to us is knowledge and information, which we're going to use and we're going to pass on to the next generation of young people coming up who are interested, hopefully, in science and in the nature of the universe.
Our next caller is from British Columbia. Go ahead, please.
Yes, my question is, what did the high-speed photometer do before they removed it? And my second question is, how close a picture will the Hubble Space Telescope be able to take of the surface of Mars?
The high-speed photometer was a device that was designed to look at very compact objects, things like black holes, neutron stars, and white dwarfs, the corpses or the remnants of stars that have burned out all their fuel and collapsed down into small states. Some of these objects spin very rapidly or pulsate very rapidly, and the high-speed photometer was basically a light meter. It was able to measure the brightness of these objects as quickly as every 10,000th of a second. So if you had a rapidly spinning pulsar, for example, you could see the individual flashes coming off the pulsar, or in the case of a white dwarf, you could see the breathing in and out of the star as it oscillated in and out. That unfortunately had to be removed. The high-speed photometer had to be removed in order to insert COSTAR in the Space Telescope to correct the optics of the rest of the telescope. And I'm sorry, what was the second question again?
How close a picture will the telescope be able to take of the surface of Mars?
Sure. We'll be able to take significantly more detailed pictures than we have in the past. We'll be able to see a lot of the large craters on the surface, some of the large canyons that run across the surface, and we'll be able to watch the changes in the polar caps as the seasons change on Mars.
By the way, the Space Shuttle is now flying over the state of Florida. If you look out your window right now, you might be able to see it high in the sky, moving over, looking something like a shooting star. We're going to take a break. We'll be right back, and hopefully we'll have more pictures from the astronauts as they try to replace a black box that is faulty aboard the Space Telescope. Stay with us. Welcome back. Good news from space. Story Musgrave has managed to replace the solar array drive electronics box on the Hubble Space Telescope. We can't see him up there as he works right now, but we just heard him on the two-way radio telling ground controllers the new unit is in, and one by one he's plugging electrical connectors that look just like this into the side of the new unit. And that's a good sign. That's a milestone. They were having some trouble getting the old unit out. It'll be stowed in the cargo bay and returned to Earth. Michael Shara of the Space Telescope Science Institute. That is pretty good news. It took them about an hour and a half longer than they had expected, but they got the job done. We've got some more phone callers to bring into our conversation. The first one from Illinois. Go ahead. You're on CNN.
Yeah, John, this is Olin Gooden of Virden, Illinois. I got a quick comment and then a question.
Sure.
I was there when they walked on the moon, and now you're doing this. You guys are doing a great job.
Yeah,
Which do you think's the most exciting? The fireworks in Iraq that you broadcast or doing this?
I think for a short period of time, the fireworks in Iraq might have been a little bit more exciting than this, but I must tell you, I'm very excited as I watch these astronauts work 320 or so miles above us. It's very interesting. Somebody asked me, what are you ever going to do in your life that was exciting as being bombed by the United States government for a few days and nights? And I told them, I think the only thing that might give you the emotional rush of that would be riding a space shuttle into space and being live on television for the first 8 or 9 minutes of the launch. I'd like very much to do that.
This is certainly a more constructive and hopefully more educational experience.
I would say you're absolutely right, Michael. Our next caller from Ontario. Go ahead.
Thank you. My name is J.J. Rogers. I'm calling from Timmins, Ontario. My question, first of all, for Michael Shara, then for you, John. A friend of mine has spent 14 years now developing and working with the high-speed photometer, and he's obviously devastated at the loss. Where can scientists working on this area get comparable information, or will they have to make do with lesser observations?
The high-speed photometer did have some really wonderful, unique capabilities, and none of the instruments left on the Hubble Space Telescope has exactly those same capabilities. On the other hand, the spectrographs can take data very, very quickly, and some of that data can be reconstructed to yield information about variability, though certainly not at the millisecond level that the high-speed photometer was capable of doing. Some observations, not quite as good, not quite as fast as the high-speed photometer, can be done from the ground, but the problem is that the Earth's atmosphere tends to blur these very, very high-speed changes that the high-speed photometer was meant to see. And so right now, unfortunately, those particular observations are really not going to be doable anymore.
Okay, our caller in Ontario, are you still there? I guess not. Let me give you an update on something else that's been a problem with the telescope in the past few hours. The solar arrays were supposed to be extended out from the side of the telescope. As you know, they are now in this position along the side of the telescope. Ground controllers were going to send a command that would get them to fold out like this so they could be unfurled later. One of the astronauts is going to go up on the robot arm to the very top of the solar arrays where they should fold down from and give it a little nudge. Michael, how delicate must that nudge be?
Well, if you're in a situation like that, first you give it a very delicate nudge, as delicate as you can manage, and then you give it a slightly harder nudge, and then you keep on nudging harder and harder until something happens. At this point, I don't think there's really much choice. None of us are very happy about the astronauts having to go up there and do this manually, but they've trained for this kind of contingency, and I'm sure they're going to be as careful as possible.
All right, you see there astronaut Greg Harbaugh, who just leaned back in the chair. He was one of the astronauts trained to be on this repair mission. He was the 8th astronaut of the 7 who were chosen to do the mission. If one of the others had gotten sick, he'd be in the shuttle right now. He's the capsule communicator. He's been talking back and forth with the astronauts for all of their spacewalk time, and he is leaning back, probably breathing a sigh of relief now that the first mission of the night has been accomplished, or is at least on the way to being accomplished. Our live coverage will continue. Stay with CNN. Welcome back to CNN's live coverage of the mission of Space Shuttle Endeavour. Let us take you down to the live picture from the Johnson Space Center in Houston, Texas right now, where you can see astronaut Greg Harbaugh standing up. He's the capsule communicator. He is talking to the astronauts, giving them information and direction from other people down there on the floor at the Johnson Space Center. I believe to his right on your screen is Milt Heflin, the flight director, who was the lead flight director for this mission. Heflin was just making a point to the controllers, the people who were talking to the astronauts and backing them up down there in Houston, that they don't have at this point the luxury of time that they've had on previous spacewalk missions. The fact is that the astronauts have taken a long time to do the first job in their list of things to do tonight. They have 3 or 4 more tasks to perform, including freeing the solar panels, going up to the top of the telescope and putting some covers on magnetometers that are there. And so the word being given to the people down at Mission Control is, let's not waste any time. Let's make sure we move things along as quickly as we possibly can. So what we can listen to commentator Kyle Herring as he talks about the current status of the mission.
Cover of the compartment on the telescope, and they're winding up the task by tightening up the small screws on the connector pins.
Describe it to the ground. The bottom is at about maybe 2 millimeters. The top is all the way in. I don't know how long the pins are.
You can hear Jeff Hoffman there talking about the length of the pins to put these computer connectors back on. Well, we don't have live pictures from space. This is what it looks like where the astronauts are working. It's a picture taken about a few minutes ago when they were working there. We're taking viewer phone calls from you to get your thoughts and comments and questions about how this mission is going. Our next caller is from Missouri. Go ahead.
This is Bill Starks from Old Monroe, Missouri. I want to congratulate CNN and you, John, for your fabulous commentary and comments on the telescope. I have 2 questions.
Okie doke.
First one, is it possible for the Hubble telescope to pick up the Voyager spacecraft that is flying out to infinity or to outer space? And the second question is it possible for the general public to buy a telescope strong enough to pick up the items that were left on the moon by Neil Armstrong and his crew?
Both good questions. Michael Shara, what do you think?
Unfortunately, the answer to both of them is no. Both Voyagers are much too far away to be resolved with the Space Telescope. On the other hand, there was a real chance of seeing the Mars Observer as it deployed itself into orbit around Mars, if that had worked. The only problem was that Mars was too close to the Sun, and the Space Telescope is not allowed to point close to the Sun, within about, say, 45 degrees of the Sun. On the other hand, had Mars been well away from the Sun when the Mars Observer was about to fire its rockets, there's a good possibility that Space Telescope could have seen it. So we can see an object, or at least the exhaust trail from a satellite, many millions of miles away with the Space Telescope. There is unfortunately no way, not even with the largest telescopes on Earth, of seeing the mirrors, for example, or any of the other debris that was left behind by the Apollo astronauts on the surface of the moon. Those objects are just too small.
Michael, you know, all over the world, people have commented about the loss of the Mars Observer, billion-dollar spacecraft. And we had a caller the other night who wanted to know if it might be possible for the telescope to point itself at Mars sometime when it's not around the Sun, close to the Sun, and see whether that probe did, in fact, deploy itself. If it's not spewing out exhaust gases, if it's just there orbiting Mars, could the telescope find it?
If the exhaust trail isn't being exhausted from the observer, I'd be amazed if we could see it. The thing is only about the size of an automobile, and it's not reflective enough. You need to make it hundreds of times brighter, and that exhaust trail is really the only way of seeing it with the Hubble Space Telescope from the Earth.
What's the smallest object that the telescope could see if it were not making light, just reflecting light?
It depends, of course, on how far away the object is. The resolving power of the telescope is measured in a unit called the second of arc. That is how many, I would say, thousandths of a degree. The resolving power of the telescope, when it's fixed, is going to be about 1/10 of a second of arc all the time, perhaps a little better when we really stretch things. And that corresponds to very, very small targets. For example, when we look at Mars, when it's even at its closest, 35 million miles away, we see approximately 200 or 300 resolution elements by 200 or 300 resolution elements. So it's comparable to having Mars filling your TV screen and seeing detail all across the surface of the planet.
That's a pretty good telescope.
It certainly is powerful. As I've been trying to make the point, it's a powerful telescope right now, and it's going to be that much more powerful, hopefully when we get the solar arrays deployed shortly and we get the telescope operational in the next several weeks.
The mission control team on the ground in Houston has been warned that they don't have any time to waste for the rest of this spacewalk. The astronauts have the capability to stay out in space as much as 8 hours, and that's if they continue to go back into the airlock to recharge their oxygen tanks, and as long as their physical condition allows them to continue to stay out there. But they have a lot more work to do. Our next caller is from New Jersey. Go ahead. You're on CNN.
Hi, John. This is Pamela Edwards from New Jersey.
Hi.
And I just have two quick questions. I'd like to know, how come we can never see the stars when we look away from the space shuttle? Like we see them down here on Earth, and can the astronauts see them? And I'd just like to know, where is the Voyager now? And how far away is it?
Okay, we can't see the stars because there's so much light reflected from the flashlights of the astronauts. I guess if they turned all the lights off, you see the picture on your screen now, if all the lights were turned off and the camera in the payload bay were pointed out toward the stars, and you know, the volume control on the video of the camera were turned all the way up, we probably could see stars. The astronauts certainly can and do, and tell remarkable stories about them. Michael, you want to answer the other part of that question?
Sure. Let me just add that what's doubly remarkable is that the astronauts can see the stars 24 hours a day, whether the sun is above the horizon or not. And that's because there's no air up where they are. The reason we don't see the stars during the day is because of scattered sunlight. The reason the sky appears blue is because of scattered sunlight. And the intensity of the scattered sunlight just overwhelms the stars. But the stars are all there, even during the day. Out in space where there is no scattering, you just look up any time and you can see the stars. Now, when the sun is above the horizon for the astronauts, it's harder to see the fainter stars, but they can still see lots of stars even in the middle of the day.
Space shuttle, excuse me, go ahead, Michael.
Yes, the Voyager spacecraft are both beyond Pluto at this point, heading out into interstellar space. They're not going to turn around, they're not coming back. They're the first messengers from planet Earth, and many tens of thousands, perhaps even millions of years from now, they'll start wandering by some of the closest stars to the Earth.
Space Shuttle Endeavour, unlike the Voyager, is over Western Africa right now. It's moving into sunlight, or will be in the next 10 or 15 minutes. We should be getting more live picture from the shuttle as soon as it gets into the sunlight area, and we'll be able to see the progress being made by the two astronauts out in the cargo bay. Our next caller is from Quebec. Go ahead, you're on CNN.
Yes, hi. I want to compliment you first on your great coverage. And my question is, the U.S. evolved through a really rich history of exploration. Why do you think there's a perception that Americans don't lionize the work of NASA more?
I wonder about that myself sometimes. I mean, the people, the astronauts, are doing some exploring in places, as they used to say at the beginning of the old Star Trek TV show, places where no man has gone before, and it is interesting. I find that the work that NASA astronauts and the managers and the other people there do is quite interesting. Michael, what do you think?
I think that a lot of people in the United States, and I think that a lot of people around the world, are still very turned on by the work that NASA does. The interest in the launch of the Space Telescope mission was enormous. There were millions of people who flocked to Florida to watch that launch, and there are huge numbers of people who came down to Florida to watch the repair mission launch. So I think that a lot of the American and a lot of the world's public is still very, very interested in what NASA is doing. At some level, NASA and the people in NASA have been victims of their own success. They've succeeded so well almost all the time with the shuttle and with space missions that people have begun to take it a bit for granted. And when another shuttle is launched to do some scientific work in space, people say, well, okay, another shuttle mission, nothing terribly new. But there are things being learned all the time. It is expensive to launch the shuttles, and NASA plans every mission very, very carefully. This particular mission happens to be a very, very high-profile mission, and I think that's why it's drawn all of the coverage. But I still think that a lot of people in the United States are very, very turned on by NASA and by the important work that it does.
All right, our next caller's from New Jersey. New Jersey, go ahead. You're on CNN.
Yeah, hi there. My name's Chris. I'd like to say that I'm really glad that you're doing this kind of work. You know, I really find it fascinating. I was wondering if you could explain to me the gravitational force that's holding the telescope in orbit. And is it a type of field of some sort? And what's it comprised of?
In simple, easy terms, there's a kind of balancing act that's going on. The telescope is moving around the Earth very, very quickly, and so it feels a kind of pseudo-force, a kind of which we call centrifugal force, that's trying to push the telescope away from the center of the Earth. Gravity is pulling the telescope in towards the center of the Earth, and those two are basically in balance. So the telescope is continuously falling towards the Earth because of the Earth's gravity. It's continuously moving away from the Earth because it's trying to stay on a tangent, and those two balance exactly. And the net result is a nearly circular orbit of the telescope around the planet.
I was just listening in to the NASA channel in one of my ears on this little radio receiver, and I've just heard the instructions going up to the astronauts for how they're going to deploy the solar panels, which are attached to the space shuttle. That's going to happen one solar array at a time, and the astronauts will stay fixed on the robot arm while the telescope itself turns from one solar array to the other. We're going to take a break. We'll be right back. Hopefully when we get back, we'll have some more live pictures from space as Endeavour comes into sunlight for one more time on this extraordinary mission. Stay with us. A job that was expected to be relatively easy in repairing a minor part of the space telescope has turned out to be a big time consumer. This is the scene in Mission Control in Houston. You can see not very many happy faces. The mission managers are looking very concerned. Milt Heflin, the man in the middle of your screen who's taking a drink of coffee right now, just told his mission managers that they don't have a minute to spare. They have to make sure that the other things that they want to do while the astronauts are out in space get done as quickly as possible. Astronaut Story Musgrave just talked down to the ground telling him he was sorry it took so long to replace the solar array drive electronics box in one of the doors on the side of the space telescope. And that part of this mission certainly did take a lot longer than anybody had anticipated it would take. The astronauts next are going to go up at the top of the telescope and put a couple of covers on some equipment that's up there. Then they're going to come down and force open the solar arrays, which are still stuck to the sides of the telescope, make those arrays extend outward. And we're hoping to get a live picture from the shuttle so that we can see the astronauts as they do these various missions. Right now they're out of touch with communication satellites, but we're not. We're in touch with a viewer in Toronto. Go ahead.
Hi, good day. My question is regarding the corrective optic package and some of the other equipment that they're putting on. Now, is any of this stuff in any way going to be blocking some of the incoming light, thereby limiting the aperture or changing the focal length of the telescope in any way?
Michael?
The aperture of the telescope will remain exactly the same. The positioning of all of the corrective optics is just in front of the detectors. So what you have is the converging beam. All of the 94 inches worth of the mirror is still there collecting photons, but in the last little bit of the way, as those converging photons are trying to reach the detectors, they get bounced off a mirror onto a second mirror, and that mirror has the funny shape which precisely corrects for the spherical aberration in the primary mirror, and then deflects the beam into the detectors. You're certainly correct about the focal length being changed. The focal length is increased, and that changes the magnification. It increases the magnification slightly for the instruments, gives us a slightly smaller field of view, but a slightly higher magnification, and that's perfectly okay.
Since we don't have pictures from space right now, we're going to show you some NASA animation of the solar array deployment as it is supposed to take place. What you can see here is the Space Telescope, which has the solar arrays, in fact, deployed on the outside of it. That's what they want to have at the end of this, this mission tonight. Those arrays both rolled out to their full length. And after they are rolled out, you'll see the telescope will tomorrow at about 2 o'clock Eastern time in the morning be lifted out of the cargo bay. The aperture door at the top will be opened. You see that happening there to make sure that that door will open under its own power. And the telescope will be placed in its orbit, and the space shuttle will move slowly away. That's the last important part of this mission. Michael Scherer, I didn't know that they were going to leave the aperture door open as the shuttle was moving away. Is that not dangerous? Isn't there a possibility that by doing that, some of the exhaust gases from the shuttle could get down into the telescope?
That's certainly true, and we'd very much like to avoid that, and they're going to very carefully make sure that they don't point the jets at the telescope. On the other hand, think of a worst-case scenario, as NASA has to. What would happen if we had the aperture door closed and the shuttle moved away and then we couldn't open the aperture door? We'd be in very deep water. The astronauts would then perhaps not have enough fuel to get back to the telescope. It would be absolutely essential that they do a spacewalk in order to open the aperture door. So we want the telescope right next to the shuttle so that the astronauts could go out again in an emergency spacewalk and open that aperture door before they leave the telescope.
All right, the telescope and the shuttle Endeavour are over Central Africa right now, and we should be back in communication with the astronauts so we can provide you with live video within the next 3 or 4 minutes. Our next caller is from Missouri. Go ahead, you're on CNN.
Hello, this is Don Schultz.
Hi.
I'm curious, the astronaut that's at the end of the robot arm,
Story Musgrave right now, yeah.
why can't he actually control the robot arm? Why does he have to signal back to, like, Claude to control the robot arm? Why can't they do something with, you know, inside his suit or something like that so he can control it?
Because he's too busy doing other things. The fact is, when you're out there in space, you get tired more quickly. You have a lot of things that you have to worry about doing with your hands and with your feet just to stay balanced there. The NASA engineers and managers met for years trying to determine what the best way to run the robot arm was. And the Canadian-built arm was decided to be operable from inside the Space Shuttle cargo bay, just because the astronaut outside has a lot more to worry about than steering himself left and right out on the end of the arm. Our last call, or our next call, from British Columbia. Go ahead, you're on CNN.
Is this me?
Yeah, go ahead.
Yeah, hi. I'm just curious. Is the Hubble a step towards inhabiting our orbit in space station?
Not really a step towards space station, but the fact that the astronauts can go out in the cargo bay of the shuttle and fix the space telescope is certainly something that would give advocates of a space station built by astronauts working in a space shuttle some ammunition in case somebody wanted to eliminate that project. The fact is that the U.S. space station is designed to be built by astronauts floating around in the cargo bay of a space shuttle. The individual parts of the space station would go up to space in the cargo bay, and they'd be assembled by astronauts working very much as these astronauts are. The robot arm for the space station will look virtually identical to the robot arm that the astronauts are working on right now. All right, we have, well, we almost had live picture from space. We'll be getting some more momentarily. We have a caller from California. When you see a flash of a picture on television, now we do almost have live picture again. It pops up for a second or two as the communication satellite and the shuttle connect to each other. We'll wait for the picture to be established completely before we show you that the astronauts continue to do their work. I just saw a flash of them outside. They seem to look all right. Our next caller from California, go ahead. You're on CNN.
Hi, my name is Douglas A. Pelton. I'm calling from Monterey, California. Hey, you guys are doing a great job.
Thanks, Doug. Thank you.
I've been watching the past couple of nights, and I've noticed two things from the NASA animations that are shown while the shuttle's out of satellite coverage.
Yeah.
The first is pretty simple. Yesterday, the shuttle was orbiting backwards, and today it seems to have turned around and is facing forward, like they're showing right now. Is there any particular reason why it turns around like that?
It's not terribly important which way the nose of the shuttle is pointed at any one time, but whether the bottom or the top of the shuttle is pointed outwards is important. Basically, you want the panel, the tiles, the heat tiles, pointed outwards towards the sun. That helps to provide some protection against overheating and dumps excess radiation back out into space during the night. So it's the up and down of the shuttle, not the forwards and backwards, that's important.
And sometimes it has to be tilted to fire the rocket engines for various steering maneuvers.
Right.
That was done once when you'll remember, the solar panel was dropped overboard. The rockets had to be fired a certain way to get the shuttle away from the solar panels. What you see now is our live picture from Endeavour. Story Musgrave at the end of the robot arm is closing the door over that electronic black box that he had to repair earlier. Behind him you see on the left of your screen Jeff Hoffman, who is just sort of holding on to Musgrave's body as the astronauts continue to do their work in space. They've got several problems to solve before they come back inside. They have the ability to stay out for at least another 4 hours, but they have a great deal of work to do in that 4-hour period. As soon as this latch on this door gets sealed completely, the astronauts are scheduled to go up to the top of the telescope to put some things that look like party hats made out of gold foil on magnetometers on top of the telescope to prevent any waste material from coming out of those magnetometers and polluting the telescope itself, going down into the barrel of the Hubble. When that's done, the solar arrays will be given a little help from the astronauts to force them to unfold and provide power to the telescope. It's expected that that event on the timeline will take place perhaps 2 to 3 hours from now. The astronauts not having as much luck as they've had in previous nights. We'll be here to continue our coverage as the shuttle mission continues. Stay with CNN. Andrea, we need to go immediately upstairs to the Endeavour cargo bay where astronaut Story Musgrave, who is almost invisible on the right, and his partner Jeff Hoffman are about to free one of the 2 solar arrays. Let's listen to NASA commentator Kyle Herring as he describes what's happening.
Drift, if you will, and there's no control of its attitude. At the start of a free drift period, though, it's usually the case where the vehicle is very stable, so there is not much drift, and there's only a slow degradation of the attitude that you originally start from.
We're going to have socks kind of lay you down on your back like KT had to get to stay under that.
Well, the solar array is a sort of an orange-looking device. It's all rolled up in a cassette. It looks like it's about the shape of a roll of paper towels. It's now parallel to the side of the Space Telescope. What the astronauts have done is climbed up to the top of that solar array panel, and they are trying to remove some latches and make sure there's nothing inhibiting the solar panel cassette from dropping down to a position perpendicular to the side of the Space Telescope. It has to be in that position for the array to unroll.
Okay. And Jeff, your backpack's pretty close to the telescope there. You can get your feet down, I think.
You see Jeff Hoffman there with his feet against the side of the robot arm.
Yeah, that looks better, guys.
The astronauts have been told to do what they're about to do very, very carefully.
A little forward, please.
Michael Shera joining us with his expert commentary.
You want to ease up to your left and take a lot of time and go look at that micro switch guard. I imagine Houston would like to have it pushed out of the way while we're here.
There's a micro switch guard at the top of the solar array, and when the solar array was being installed by astronaut Kathy Thornton a couple of days ago, that she pointed out that it might need to be moved out of the way.
Okay, I'll stay here.
Jeff Harbaugh was just instructed to move up and remove the micro switch cover, and then Houston came on and overrode the earlier order and told him not to. As the Endeavour continues to go over Africa, our picture may break up a little bit temporarily, but this is such a tense moment for the astronauts. If we can bring you a live picture of it and let us see whether the solar array can be freed, we'd want you to see that picture. Michael Shera, while we're waiting for communication with Endeavour to be reestablished, you can see the desperate flashing lines as the people in Houston try to reestablish communications. How important is it that the astronauts do this job and get the solar arrays out?
It's absolutely essential. The solar arrays provide the only power source for the Space Telescope, 5 kilowatts worth of power. Without the power supply, We can't move the telescope, we can't point the telescope, we can't take data, and some of the instruments without power will simply freeze up, break, and we will lose the telescope. They must deploy these solar arrays, and they must do it now.
Shuttle Endeavour is between Australia and Africa now, moving toward Australia. Andrea, we're waiting for more live pictures while we wait. I know you have more news for our viewers.
We do, John, and pictures are available for the Hubble repair, and here with live commentary is CNN's John Holliman. John?
Andrea, the astronauts have successfully managed to get one of these solar panels for the Hubble Space Telescope deployed. What they're doing right now is both astronauts, you see Jeff Hoffman on your left, and behind him Story Musgrave, are waiting for the telescope to rotate around so that they can deploy the second solar panel. If you look very closely over the astronauts' heads in our picture, you can see there's something that looks like a bar extending from the side of the Hubble Space Telescope. That bar is one of the two solar array cassettes which will eventually, in the next 2 or 3 hours, be unrolled to provide power to the battery of the telescope to keep it going for the next many years. Michael, how does it make you feel to see that solar panel in the deployed position now?
Well, I'm starting to breathe a little bit again. Without the panels, we were really in serious trouble. Now that we've got at least one out, we're hopeful that we're going to get it arrayed, and we'll be getting back 2.5 kilowatts into the telescope, which is certainly enough to keep it alive and keep it functioning at some level. But I'm not going to be really happy until that second cassette is fully deployed perpendicular to the telescope.
This is quite a picture. You see Earth in the upper right-hand corner of your screen. You see the two astronauts both at the end of the robot arm. It appears that they are moving. They're not moving very much. In fact, the Hubble Space Telescope is moving. It is sitting on a carrier which is very similar to a lazy Susan you might have on your dining table. Actually, the robot arm is moving a little bit to the left to let the astronauts get over to the other solar panel, which you can see now with the Earth in the background is still attached to the side of the Space Telescope in the wrong position for it to unfurl a little bit later. The astronauts have been told to be very careful with what they do, but they've also been told not to waste any time at all. The spacewalk is limited to approximately 8 or 8.5 hours. They have been out in space for more than 4 hours, and they have considerably more work to do before they come inside at the end of the spacewalk. If the NASA managers decide to make this the last spacewalk of the mission, and we've been told they have made that decision, then the astronauts are going to have to clean up everything in the cargo bay before they get back inside, because the cargo bay doors will be closed without any astronauts out there to do any more cleanup work. So their time out in the cargo bay has to be spent very, very wisely, as well as efficiently and carefully, to do all the various jobs that are required of the astronauts. We might want to listen in and see as the astronauts talk to each other and mission commentators come on the line to see what it is exactly they're talking about as they use their time on this spacewalk.
Got wrapped in the French hook.
The telescope's now been rotated back around so that the two crew members can access the other solar array. Claude Nicollier now operating the shuttle's robot arm, and Kathy Thornton mentioned that she's been waiting a year to do that after training for this flight and simulators to actually get to rotate the actual telescope is what she was referring to.
Well, Kyle, she was referring to the hard stop. Normally there are devices on board any mechanism that we have, and there's that limits the travel, and when in the case of the telescope, when it rotates, it can only rotate so far, and we never really go to the hard stop as it is, so to speak. We always just go to a few degrees off of that. In this case, we went right to the hard stop for ease of access for the crew and moving the arm to the other side. And Kathy, in fun, has said she's been waiting to do that an entire year because they never let her do this before.
Remarkable picture from space. Planet Earth slowly spinning beneath the telescope.
Completes this task of manually folding down the solar array. The telescope is in the proper position for the next task, which is to install the Goddard High Resolution Spectrograph Redundancy Kit, which is a series of cables to help improve the redundancy of that operation of that science instrument.
That's a part of this mission we haven't talked about very much, Michael, the Goddard high-resolution spectrograph. What does it do?
It's a device that takes light from the telescope, passes it through a series of light-dispersing elements, and breaks the light up into a spectrum, essentially a rainbow, and allows us to make very precise chemical measurements on stars and galaxies, as well as measure very precisely how fast objects are moving towards or away from us. Half of the instrument failed because of this faulty power supply over a year ago, and by installing what are essentially jumper cables, we're going to be able to use the working parts of the power supply now to get back the full functionality of the spectrograph. Only half of it is working right now, and we really want to have the full potential of that instrument back online.
All right, let's take a quick break while the astronauts prepare to lower the second of 2 solar panels. When we come back, we expect to see them live from space doing just that. Stay with CNN. Welcome back. Astronauts Jeff Hoffman and Story Musgrave are out in space, about to manually extend one of the solar panels for the Hubble Space Telescope to help it generate the full 5,000 watts of electricity it needs to power the instruments inside the telescope. We're going to listen to them as they get instructions for lowering this panel. They've been told already they don't have much time to do this, but they've also been told to be very careful as they do it. So we'll listen as they talk. Musgrave is on the right of the 2, Hoffman on the left. Ken Bowersox, the shuttle pilot, is now operating the robot arm. This is an unexpected, well, not unplanned for particularly, but an unexpected additional event for the astronauts in this spacewalk. They were hoping that the mechanical devices, electric motors on board the telescope, would automatically lower these solar panels into place. What we expect to see happening is the robot arm going up to the top of the solar panel array.
Okay, we're about 1.5 feet.
Story Musgrave asking his pilot, Bowersox, to move the robot arm about 1.5 feet closer to the telescope.
Keep going, Quad. Keep going, you got 1.5 feet in the telescope. Go up 6 inches, 2. That's good, now up 6 inches. That's good, Claude.
The bright curved light you see in the upper right-hand corner of your screen is the Earth, reflecting sunlight as the Endeavour goes over a part of the Earth that's in daylight.
The astronauts have practiced this particular maneuver quite a number of times. What they have not practiced and are not able to practice on the Earth is the actual unfurling of the solar arrays, and that's because we'd break them if we did. They're very, very fragile, very delicate, and you can only unroll them inside a large water tank. If you try and unroll them on the ground outside of water, they simply fall apart under their own weight. In the weightlessness of space, of course, it's not a problem. Here comes the array.
Look at the solar array. It's being forced away from the side of the telescope by the 2 astronauts there at the base. You can see it as it separates from the telescope there at the top of your screen.
This is a wonderful moment.
In progress, the manual deploy of the second solar array down to the open position. The secondary drive mechanisms that actually roll out the new solar array blankets is not done until after this EVA is completed, or this spacewalk. The payload community commenting that they are relieved to see this solar array being opened.
That's an understatement.
You are the payload community, Michael. Michael Shera, our guest commentator here at CNN Center, is from the Hubble Space Telescope Science Center in Baltimore, and an astronomer who uses this telescope, has used it for 3.5 years and would probably like to start using it again in about 6 weeks from now.
I'm going to be very happy to, and the astronauts have just made it possible for that to happen.
Well, the solar array is almost down in its final position away from the telescope. We'll listen as the astronauts make their thoughts and feelings perhaps known to people on the ground as it comes down into its final lock position. Story Musgrave is the one touching the solar array.
Okay, I'm at a nice soft stop, Tom. Okay, copy, Houston.
We copy, Tom.
All right, Tom Akers saying that they got this job done. This was a critical point in the mission. We're going to take a break now. We'll be back at the top of the hour with more live coverage from Endeavour and CNN of this Hubble Space Telescope repair mission. Thanks for being with us.
And that's it for this international news cutting. We'll return to our live coverage of the Hubble repair mission right after this break. And CNN's John Holliman will be joining me to provide commentary on the mission. Stay with us. And welcome back to our live coverage. I'm starting to lose my mind here and my words. To our live coverage of the U.S. Space Shuttle Endeavour and its repair mission to get the Hubble Space Telescope back in shape. And joining me once again is CNN's John Holliman, who is bringing us up to speed now. What happened?
Bettina, you know, we've had 4 spacewalks up until tonight that went very, very well. This one is causing a lot of trouble for the astronauts. They've had problem after problem. They're behind schedule. The mission managers on the ground at the Johnson Space Center in Texas, who have had big smiles on their faces in the previous spacewalks, are frowning and crossing their arms, and they look grumpy. There have been some problems, but the astronauts are solving them. I don't know if we have live pictures from space right now to show you or not. Yes, we do. All right, these are pictures of Story Musgrave and Jeff Hoffman, who are replacing something called the Goddard High Resolution Spectrometer. It's a device that looks at the color of light coming in from stars. This spectrometer has been working pretty well. It has 2 sides, a redundant setup inside of it. If one part doesn't work, the other side does. The redundant side has not been working as well as it should, and they think it's because of a bad cable. So they're taking a new cable and connecting the B side of this piece of equipment together. Just a few minutes ago, the astronauts solved a big problem. We have some videotape to show you of that. The telescope's solar panels have been stored during most of the mission on the side of the telescope, and the astronauts needed to manually lower the solar panels. You see right there with the Earth in the background, this one solar panel that the astronauts were manually moving away from the telescope so that it could go down into the deployed position. The people who work at the Space Telescope Operations Center near Baltimore, Maryland in the United States, and the international scientists around the world who use the Space Telescope, who were watching this picture just a few minutes ago, breathed a communal sigh of relief. Because if this solar panel had not been allowed to drop down, the telescope would never have been able to work again.
But is it extended already? Have they extended it?
No, not yet. That will take place, according to the NASA commentators, after the astronauts complete all their other work outside. It's a lot easier for them to work with the solar panels out of the way than with them fully extended. And so now we're going back to live pictures. This Goddard High Resolution Spectrograph will be improved. Then the astronauts on the robot arm will go up to the top of the telescope and put some little golden, I call them party hats, that's what they look like, onto 2 instruments there to shield those instruments and prevent any pollution from inside the instruments from getting out into the telescope.
Was that necessary because something broke earlier on?
It was. It turned out, you know, the astronauts 2 nights ago had to replace instruments on top of the telescope called magnetometers, which allow the telescope to find out where the Earth's magnetic field is. It's one more device to help steer the telescope. The decision was made not to remove the old magnetometers, but to just install new ones on top of the old ones. When they went up to install the new ones, they found that the cover on one of the old ones had broken. And there's insulation there that could come out and could have gotten down into the barrel of the telescope, blurring the pictures again. And they didn't want to do that. So the astronauts, as a field expedient, found some gold foil that was left over on a piece of equipment down in the cargo bay and fashioned it into these devices. Why don't we listen to the NASA commentary for a moment or two as the astronauts continue their work.
Say again. 1,
Now, what the astronauts are doing, they're using a power tool to turn bolts on this piece of equipment that they're replacing. And what they want the ground managers to know is how many times the bolts have to turn. So they count off 1, 2, 3 as the power tool and the bolt connected to it turns.
In some other shots that we've seen earlier, from when you could see more of the telescope, it looked as if the top part is wrapped in something like aluminum foil.
The whole telescope is wrapped in a material that protects it from any hits or pings from pieces of space debris. And this material is also protecting the parts inside from ultraviolet radiation. It's, you think about it, what you can see there is down into the cargo bay, and you're seeing some gold-looking material. Turns out that material is in fact gold. Gold is the best element known to man to shield equipment from ultraviolet radiation. The astronauts have sun visors on their space helmets, which they pull down when the sun is out. Those sun visors have particles of gold in them also, again, to shield the astronauts' faces from ultraviolet light that could do permanent damage to their bodies.
If you want, we can finish the soap later.
We still got a couple more bolts to go, right, Store?
Yeah. That one is it's closed so much that I can't, I've got the bolt all the way back, but I can't open it. I'll go up and get the next two. I'll go up, please.
So did it try to kind of pushing out on your Story?
It's pushed together still, so it's holding itself in there. In other words, the door is not trying to pull apart. The door is pushed together, and that holds that little bolt there.
Okay.
I'll get this one out of work.
They've had more trouble with the doors on this space telescope. This is another door problem. And the fact is, Bettina, time is running out for the astronauts. They expected to have a 6-hour spacewalk and use the first 3 hours to do all the objectives of the mission. And they've been out in space nearly 5 hours now, and they've done one of the things that was in their original plan. That first job, which they expected to take 90 minutes, took more than 3 hours.
Musgrave continues opening the latches on the protective doors for the Goddard High Resolution Spectrograph. The Space Telescope Operations Control Center.
Latches are released.
Good news, they got the door open.
And as reported by astronaut Greg Harbaugh here in Mission Control, the high gain antenna latches are open.
One bit of good news for you. The stock and the HST project folks report that the DF and the coprocessor are considered operational. They've checked it out, no hardware problems at all.
That is good news, Bettina. That's the computer problem that we were talking about several hours ago. It appears the computer now works. And the problem was not with the computer at all, but with the communication system.
Yeah, we sure know.
That voice that you just heard who said, "we sure know," is Greg Harbaugh. He is an astronaut who was scheduled to be on this mission. When NASA trains astronauts for a crew, they train a couple of additional astronauts in case somebody gets sick.
On the coprocessor, the ground does confirm that the coprocessor, which was installed to enhance the speed and the memory of the onboard computer, is now declared operational by the Hubble Space Telescope project. There'll be no further action required of the crew for that instrument, which was installed at as the last item of yesterday's spacewalk by Kathy Thornton and Tom Akers.
That's good news
And
to
you
these
can tell,
astronauts,
Kyle, by Tom's
because
reaction to that
they
news
now,
that
that's one job that was going to take an hour that they don't have to do.
Since he and KT were the ones to install
At
it.
what time do they have to just go
hearing
back
that,
into
there might
the
have been
shuttle?
some problem
NASA tells me that
with
the maximum
coprocessor,
period of
was
time
probably a
astronauts
bit
can stay
disturbing to
outside
them,
is
but
8.5
hearing the good
hours.
news, it'll
And that is the
alleviate that.
absolute maximum. They plan these spacewalks for 6 hours. They agree to allow the astronauts to stay out 7 hours and have done that most nights. The record for a U.S. spacewalk is 8 hours and I believe 22 minutes. And that's just about the outer limit. If these astronauts aren't able to complete the rest of their jobs in a speedy way, they may not get them all done.
That's the problem.
Once again, counting revolutions on this tool.
Jeff, you got all the soap bolts torqued to 10, right?
I have 3 so far.
Okay, sorry.
Every Houston, minute and a half to early handover.
Right. Now to the left a little bit. Go to the left.
Bettina, they continue to talk about these SOAP bolts. And it's not soap like we wash with. It's a NASA acronym for Small Orbital Replacement Unit Protective Enclosure. Now, that's a box where the spare parts are stored. I don't know why they don't call it a box where the spare parts are stored, but...
Is that like a little toolbox that they carry with them?
No, it's a box in the payload bay of the shuttle. So as one astronaut is working, that's Story Musgrave, out on the robot arm, he's opening these doors and getting to the equipment that needs to be improved. The other astronaut is down in the cargo bay. We can't see him right now, but he's opened this box, the SOAP box, and he's pulling out the new cable that will be installed by Musgrave as soon as he gets the doors open and everything working effectively there on the side of the telescope. See, there's a handhold attached to the side of the space telescope. If we had a little bit different light, you could tell that it's yellow in color. The space telescope is covered with these things because it was unlike any other satellite built by humans. The space telescope is designed to have astronauts crawling around all over it. You might remember a little more than a year ago, there was an Intelsat communication satellite that the shuttle astronauts went to get. It was very difficult to get because it didn't have anything for them to grab hold to. It was spinning in space, and the only way they could stop it was to have everybody on the count of 3 put their hand on the side of it to stop it spinning. And that's the way they were able to grab it, and then they were able to pull it into the space shuttle to get it back to Earth. But the astronauts continue to do remarkable work out there in space right now.
So there probably will not be another spacewalk scheduled for in 24 hours or so?
Probably not. The thing that is scheduled right now for 24 hours from now is the release of the telescope. And here's some tape that we recorded just a few hours ago as the astronauts were out there in darkness doing the work on this particular piece of equipment, the Goddard high-resolution spectrograph. The telescope itself, quite remarkable. What is in the plan for tomorrow is that at about 23 hours from right now, the astronauts will all be inside the shuttle. The robot arm will attach itself to a point on the side of the space telescope. It'll be released from this turntable that it's been riding on for the past 5 days. They'll lift it out of the cargo bay, place it in space at the spot where it's going to do its work for the next 4 or 5 years. Then the robot arm will quickly disconnect. The shuttle will move slowly away, and the telescope will begin being lined up with all these new instruments. They'll be refocused, and the scientists on the ground tell us that they anticipate that when that happens, the telescope will be sending back these pictures that have been advertised by NASA for more than 3.5 years. We're back to live picture. Yeah. Yes.
How dangerous is that, to let the telescope go?
I think it might be quite dangerous. One of the things that the astronauts are going to do before they let it go is open the door up on the top. And it seems to me quite dangerous to have that door open with the mirrors inside the telescope potentially exposed to exhaust gases from the shuttle. The whole mission, the door's been closed so that no pollution from Endeavour can get into the telescope. But before the astronauts leave, they want to have that door open. The ground-based managers want it open because they're afraid the door might be stuck closed at some future time. So they want to make sure it's open before the shuttle moves away. This, the black disc that you see on the right of your screen, right above the CNN International Live, is one of the high-gain antennas that send pictures from the telescope and computer data from the telescope back to the ground. There are 2 of them, one on either side. As soon as the astronauts complete the job they're doing right now, or maybe even while they do that job, those antennas will fold down from the side of the barrel of the telescope and will be tested to make sure they're still operating. They've done a very good job for the first 3.5 years of this mission. No problems with those antennas at all.
Houston, we're going to be off the tail, Radicom for a while.
Well, thank you very much, John. CNN's John Holliman once again providing us ongoing running commentary. Thank you very much.
Well, it's an interesting story.
It is. It's great. It's great to have you with us. And we'll have world news in some 7 or 8 minutes. But first, international weather and international sports. U.S. astronauts Jeffrey Hoffman and Story Musgrave have been floating around the cargo bay of the Space Shuttle Endeavour for more than 4 hours now. They're making the final planned spacewalk of the mission to repair the Hubble Space Telescope. The U.S. Space Agency NASA had thought it might have to schedule another spacewalk after a piece of computer equipment installed earlier seemed to be malfunctioning. But ground trackers at Mission Control now say they believe the data glitch was from a bad radio link with the Hubble and not a faulty part. And welcome back. We'll now return to our live coverage of the U.S. Space Shuttle mission. And CNN's John Holliman will provide running commentary.
Fingertip with a mushroom. Okay. That's a good cloud right there. Okay. Now to the right, Claude. To the right. Stop. And you've got to walk that bottom striker plate.
Astronaut Story Musgrave buttoning up another set of doors on the Hubble Space Telescope. Inside those doors, the Goddard high-resolution spectrograph. You can see how shiny the skin of the Space Telescope is. Musgrave almost as clear in his reflection on the right as he is in person on the left. Let's listen in as he works on this door. You know, on previous spacewalks, if you've been with our coverage, they've had problems with the doors. Let's see how it's going with this one.
Same kind of encouragement. I'm just going to wait for you to get here.
You see floating in weightlessness, there's a pin. That pin is the latch for that door. One of several latches. Musgrave is asking for help from his partner, Jeff Hoffman, who's down below in the cargo bay.
Do magnetometers. That's probably a good idea, Story. Why don't you come over and pick him up, and then you guys go close that door. We know it's going to close. Okay.
So the astronauts are running out of time in the spacewalk. They've been in the cargo bay for more than 5 hours now. What they just decided to do was, instead of waiting for Jeff Hoffman to climb up the telescope to where Musgrave is, the robot arm is going to zoom him down, pick up his partner, and bring the two of them back up there, because they've had so much trouble with the doors on previous door closing attempts. They're going to get both astronauts up there to do it together. While we wait for the robot arm to go and pick up Jeff Hoffman, we'll take a break. We'll be right back with continuing live coverage from Endeavour and CNN. Two astronauts zooming through space, also zooming through the cargo bay of the Space Shuttle Endeavour on the shuttle's robot arm. You see astronaut Jeff Hoffman at the bottom of your screen. He's just climbed off the robot arm. Up on top, Story Musgrave, the senior spacewalker and payload commander for this mission. As they have in the past, they have a little trouble getting doors aboard the Space Telescope to close. The two of them are working hard at this job right now. As they work, we'll listen in.
Take me a little bit away. Okay, well, I'm not going to push until you tell me you're ready. I'm not even on the handle yet. Yeah, I'll just wait. Hang out. And my bar is going to be above you here.
Story Musgrave will try to use the handle while his partner Hoffman down below will push the right side door in.
Question. Roger. Okay, Jeff. I'm starting to walk the doors. I'll walk them. Bottom feels good. Looks good. I'll put the tip pin in, go look at the top. Tip pin's in.
Managed to get a latch pin in at the bottom in the center.
The touch cloth. Okay, out a foot. Up a foot. Looks good. See? 3. I don't know about this side. I haven't. Yeah, it's nice. Okay, it moves nice. It just moves bolting down, I think. Yeah, it does not feel like the other one. That's just... All right. 23-4, Titan.
In the center of your screen there, you can see the latch on the telescope between the two yellow handles, one on either door. You can see Jeff Hoffman will be using a power tool to attach a bolt to a pin that goes through that latch to seal it.
Coming this way, Jeff.
That's Jeff Hoffman, who you see, and you can see just at the top of your screen Story Musgrave's right hand.
Stop. Stop.
The power tool being inserted into the bolt to tighten the central latch on these two doors. It's very difficult to maneuver in space because you're virtually weightless and you have nothing to hold on to. And if Jeff Hoffman weren't firmly attached to the side of the Space Telescope, as that drill spins one way, he would spin the other way.
Get the other bolts now. Now down, please, Claude. Down. The top's coming in just fine, Story. Yeah. I gotta drop these other guys in and finish the handle bolt. Good, Claude. We'll get this bottom one in. Hey, Jeff, I hate to make you go work, but would you mind coming and closing the cope out because we still have to rotate? I'm going to do that. Get us a little ahead. I'm on my way down. Okay, thanks.
The astronauts are on a very tight schedule here. They were told just before, about 8 minutes ago, that they only had 25 minutes to get this door sealed because they needed to get it sealed before the sun's angle in the cargo bay changed. You can see there's pretty good light in the cargo bay now. Sunlight reflected off planet Earth down into the cargo bay. We can't see the Earth because it's up above the heads of the astronauts now, looking like the sun would look to us here on Earth.
That ought to hold it. Let's finish up the handle bolt.
These bolts are tightened somewhat similarly to the way you would tighten lug nuts on your tire when you change a tire. The nuts tighten partially, and then they go back and tighten them firmly. These power tools are pre-programmed to only spin the proper number of turns to tighten the individual bolts, so they won't be over-tightened or under-tightened.
When you get there, to the left. Okay.
A couple of additional jobs for the astronauts in the next hour, perhaps, including putting some covers over magnetometers at the top of the telescope. When that's done, the astronauts will go back toward the airlock and watch as the solar panels are unfurled. Hopefully, they will come unfurled using the motorized, the motors that are in there designed to do that job. But if not, the astronauts will come out and manually unfurl the solar panels so that the telescope can get electricity after it's disconnected from the shuttle's power supply.
A little more. Bit further down.
The astronauts have been out in space for 5 hours and about 20 minutes now.
Roger that.
Their colleagues inside the shuttle's crew cabin and on the ground are hoping that the solar panel deployment will be accomplished without any astronaut help, because it'll be very time-consuming to do that job manually, perhaps. And the goal is to let the machinery do it so the astronauts don't have to. This is the 5th night of spacewalks, and in the 4 previous nights, the astronauts have had very little problem, and this last night has been one where they've had several things crop up that needed their attention that they weren't scheduled to do ahead of time.
About an hour or an hour and a half ago, they were really running behind schedule, and things were beginning to look a little bit tense. But once they got the solar panels off the body of the telescope and deployed at 90 degrees, they really, I think, got a tremendous psychological boost. We certainly on the ground did. And they look like they're making up time now. With the GHRS properly hooked up, the last scientific instrument that we weren't getting proper data from is now fully ready to go. All we have to do is get those caps on the magnetometers. The magnetometers, incidentally, tell us where the direction of the Earth's magnetic field is to help the telescope point itself.
CNN Newsroom is coming up next. We'll have a live report in the newsroom broadcast, and we'll be back with more live coverage continuing throughout this spacewalk number 5 for the Endeavour astronauts. So we urge you to stay with CNN as our coverage continues.
The Endeavour's out-of-this-world telescope repair hits a glitch.
With patience and expert precision, the Space Shuttle astronauts complete a major repair to the Hubble Space Telescope.
One official with the $600 million plus repair project called the fourth spacewalk eye surgery.
What he's referring to is the replacement of CoStar. In the wee hours of the morning Wednesday, the Fix-It team of Kathy Thornton and Tom Akers removed a refrigerator-sized box containing a light meter. They replaced it with one called CoStar, which contains 10 small mirrors. The new addition should give the space telescope perfect 20/20 vision.
We've got basically a new telescope up there, and it can be real exciting for the astronomical community, I guess, and for the whole world to see what do with a good set of eyeballs.
Now it's up to the space engineers on the ground. It's their job to fine-tune the optical systems and get the telescope back to work. Meanwhile, during Wednesday's successful walk, Akers had reason to celebrate. He set a U.S. record by spending a total of 29 hours and 40 minutes walking in space. And he even had time to blow a kiss to his family, watching from home in Houston.
Now, also on Wednesday, the astronauts opened an equipment bay and added an upgrade to the telescope's computer system. The part was supposed to help the Hubble computer become faster, but there was a glitch, we found out.
CNN correspondent John Holliman updates us on the mission now, including Thursday's spacewalk. John?
Well, for the first thing, why don't we go out and show you a live picture from space. This picture of astronaut Story Musgrave doing some repair work on the Goddard high-resolution spectrograph. He's added a new cable to connect it to the rest of the telescope's electronic equipment. And you see he's using an electric power tool to tighten the doors that cover that piece of equipment right now. The glitch with the computer, it turned out, was a radio communications glitch rather than a problem with the computer itself, and that's good news. That means the astronauts won't have to do any more repair to the computer. It'll have a 386 power chip rather than the 286 chip, or in addition to the 286 chip that was with the original computer, and also a great deal more memory. The astronauts in the past 5 hours in space have replaced a solar array drive electronics black box, which will help the solar arrays point themselves at the sun better. The solar panels themselves were supposed to be extended by motors. They weren't extended. The motors were not able to make them fall down, so the astronauts gave them a little mechanical help, and those solar arrays are now down. The solar panels themselves have not yet been extended. That'll be the last thing that we see on this mission. And as we say, astronaut Story Musgrave right now is closing the doors, the payload bay doors on the telescope, which cover the Goddard high-resolution spectrograph and some other equipment inside the shuttle. You can see Musgrave is seeing himself in the shiny surface of the Hubble Space Telescope right now. The next job up for the astronauts, the two of them will get on the robot arm together, and they will ride to the top of the Hubble Space Telescope and add a late last night invented repair fix to equipment at the top of the telescope, which might eventually leak some insulation that could get down into the telescope and spoil some of the pictures that ground-based scientists say they're expecting to get from the Hubble beginning as soon as 6 weeks from right now. The mission has been behind schedule almost from the start, but the astronauts are beginning to catch up, and they may well be available to watch those solar panels deploy in about an hour.
John, earlier when we heard there was a glitch, there was a possibility of another spacewalk. Is that still a possibility?
That's right, Cassandra. They thought that if there was a problem with the main computer aboard the Space Telescope, the astronauts brought up a spare computer, and it's identical to the one that is already installed, except all of its memory chips work. And there was some suggestion that maybe they would have to install that. And as it turns out, the new computer is working, or the old computer is working just fine, and it turns out that the attachment fixture that was put on by the astronauts last night is also working fine, so that computer problem appears to be not a problem at all. And that's good news. The astronauts have been outside at this point, 3:50 Eastern time in the morning for about 5 hours and a half. They have another 2 hours that they could stay outside, but their managers would like to get them in as soon after 6 hours as possible.
Okay, CNN's John Holliman.
U.S. astronauts Jeffrey Hoffman and Story Musgrave are making the final planned spacewalk of the mission to repair the Hubble Space Telescope. Earlier, the astronauts had to pry loose the telescope's solar antennas with their hands after motors failed to lower them into position. Meanwhile, NASA figured out what was causing errors in the flight data from the telescope and said a 6th spacewalk to fix the problem won't be necessary.
And were removed by Jeff Hoffman on the 3rd spacewalk. That box is now in place. He's preparing to put the same size box, the same type of box on the 1st magnetometer. Simply as a precaution, that sensor box did not have any problems with the outer covering, but the prudent thing to do would be to go ahead and place a box over that sensor and secure it with the tie wraps, just as they did on the 2nd magnetometer just a second ago.
Join CNN's John Holliman for CNN's continuing live coverage of the mission of the U.S. Space Shuttle Endeavour to repair the Hubble Space Telescope.
To be able to stay out in the cargo bay while the Hubble Space Telescope Operations Center people attempt to unfurl the solar panels on the telescope. The reason is that their spacesuits have batteries, and those batteries will go dead before it's going to be time for the solar arrays to be unrolled. We've just briefly lost our picture from space. We hope it's a brief loss of picture. You can see now where the space shuttle is located over the ground. Well, I guess you can't. It's located off the west coast of the United States, about, well, over Hawaii almost. It'll be coming over northern Mexico in about 15 or 20 minutes, and we ought to be able to get more live picture. You can see right now on the bottom half of your screen where the shuttle is located. Once again, live picture from the astronauts as they work up there at the top of the Space Telescope. Michael Shera, how concerned are you as an astronomer who uses the telescope that these 2 astronauts are not going to be available to manually unfurl the solar panels if they're not unfurled by the motors?
Well, I'd certainly be happier if the astronauts were out there, if they were easily available, and so if there were a problem with getting the panels to unfurl, they could simply go up and winch them out by hand. On the other hand, we do have the contingency, namely that Tom Akers and Kathy can also go out if necessary and unroll them if they happen to get stuck tomorrow during a 6th now unplanned spacewalk.
Yeah, right now in space, by the way, the astronauts are still putting on one of the 2 covers on the magnetometers, and that job is expected to take just another few minutes. But the the ground-based managers are telling these guys they're not going to be able to stay out there too much longer. They have enough oxygen in their oxygen tanks, but the batteries in their spacesuits won't last that much longer. Those batteries are designed to last about 8 hours. They've been out in space a full 6 hours now, and it's not known how long it's going to take them to complete this job and clean up the cargo bay. What NASA would like to have happen this morning in the next 2 hours is the cargo bay completely cleaned up of all their tools, everything put away in its own container, so that nothing else has to happen out there and the astronauts don't have to go out in the cargo bay ever again on this mission. We have some more callers lined up. The next one from Maryland. Go ahead. You're on CNN.
Hi, this is Mike from Maryland. I have two questions about the cameras. First, what's the exposure time for the various cameras? And second, how long can all the cameras be used at one time?
The cameras that we're looking at live pictures from, or the cameras on the Hubble Space Telescope, Michael?
On the telescope itself.
Okay. Michael Shara.
Sure. The exposure times depend very much on the kind of object that we're looking at. When we're looking at a very bright object, for example, Mars or Jupiter, exposure times are typically about 1 second. In fact, we can't take pictures much faster than that because the shutters on board the cameras don't operate quite that quickly and won't give us a perfectly uniform picture. We can take exposures as long as about 30 or even 40 minutes if necessary. We try not to take pictures any longer than that, even on the faintest object, because of what we call the cosmic ray problem. There are a lot of high-energy particles, electrons and protons, up there where the Space Telescope is. Those produce artificial hits. They look like artificial stars on the charge couple devices. And so what we try and do is take 2 or 3 or 4 pictures of the same object, and then we can run them through an automatic filter in computers, and that filter will say, well, okay, I see a bright spot here at this 1 pixel of a particular image, but it doesn't appear in any of the other images in the same pixel, so I know it's an artifact caused by a cosmic ray, and I'm just going to throw it away. That's how we clean up the pictures. So to answer your question, from 1 second all the way on up to 30 or 40 minutes, depending on the brightness of the object we're looking at.
Before we take our next call, Michael, I know you have some photographs with you that have been taken with the Hubble Space Telescope, including some objects pretty far away from us.
There's one that we have here of a supernova remnant that's really extraordinarily pretty. The red area running from the bottom left to the middle center of your picture is part of a supernova remnant. That's the stuff blown out of a star that died as a supernova in the constellation Cygnus in our own galaxy. And you can see the exquisite detail in it. There's also a jet-like structure running from the bottom center towards the top center, almost like a bullet of material shot out of the remnants of the star, the central star that died as the supernova. And there's clearly an impact going on as that jet of material runs into the supernova remnant. One of the things we would certainly like to be able to do with the now repaired Goddard high-resolution spectrograph is study in detail individual pieces of that supernova remnant, see exactly what the material is made of, how hot it is, how fast it's moving. And that gives us clues as to the nature of the supernova explosion that gave rise to this exquisite cloud in space.
That is an amazing picture. I have a theory, Michael, that the best television is television that has red and yellow and orange pictures, and those were certainly red, yellow, and orange. Which instrument on the telescope was used to make that?
That picture was taken with the wide field and planetary camera, and the new WIFPIC, the one that the astronauts installed 2 days ago, will be able to take pictures with lots more detail in it than the one you just saw, and that picture is more detailed than anything we can get from the ground.
This is the picture we're looking at right now. Might tend to confuse you if you didn't think about it for a minute. The astronauts are upside down on top of the Hubble Space Telescope now, and they probably don't even know that they're upside down because there is no up or down in the situation where they are. Story Musgrave was just flexing his leg muscles as he continued to do a little work up there. He's attached to the top of the robot arm, and he's putting a golden cover using real gold foil. Turns out that gold is a wonderful element for protecting things in space from the ultraviolet light that could do damage to those things if they didn't have a cover of gold. As Michael Shara pointed out to us earlier this evening, the astronauts' face masks have a gold shield that they pull down when the sun is out, again to protect them from ultraviolet radiation. We have some more phone calls lined up. The next one from Georgia. Go ahead. You're on CNN.
Yes, sir. How you doing?
Having a good morning.
Good morning. This morning, around about 1 o'clock, I live here in Conyers, about 30 miles outside Atlanta.
Yeah.
I was looking up at the sky, looking at a beautiful sky. From east to west, I saw a flash of light that went across the sky.
How fast?
Just an eye blink. I just noticed it out of the corner of my eye.
What you were probably looking at was a meteor. There are countless billions of fragments of rock and ice that are traveling between the planets. They're in orbit around the sun just the way the Earth is, and many thousands of them run into the Earth's atmosphere every second. Most of them are too tiny to be noticed, but something perhaps the size of a thumbnail probably entered the Earth's atmosphere as you were looking up in the sky, moving at perhaps 15 or 20 miles per second. It had an enormous amount of kinetic energy, and that energy all got turned into heat as that little fragment of rock was roasted as it re-entered through the Earth's atmosphere. And it was the glow of that thing as it was burning up that you saw. That's what a meteor is.
Our next caller is from New York. Go ahead. You're on CNN.
I have a question on the highly technical tool choices that these people have to make and how they deal with improvising with what they have.
All right. Let me tell you a story that happened about an hour ago. They were having a big problem up in space disconnecting some electronic connectors from the side of an instrument on the telescope. I have a connector very similar to the one that the astronauts were trying to work with. It looks very much like a computer cable that you'd have on your home computer. The astronauts had a power tool that had a long handle, a big electric motor at the end of it, and they attempted to use that tool to disconnect these tiny screws. Story Musgrave was out there having a lot of trouble using the tool. The first hour and a half on the timeline, the schedule for the astronauts, turned out to be about a 3-hour time because that tool wasn't working correctly. Finally, Musgrave found another tool that was much smaller, and it was able to do the job almost instantaneously. So after a lot of delay trying to do what they planned to do on the Earth, Musgrave was able to improvise, use a different tool from the one that he was supposed to, and get the job done. It's happened a lot on this mission. These astronauts are very, very effective at what they do. We've just heard from the astronauts that the installation of these two gold leaf covers on top of the telescope on the magnetometers is complete. You can see now they're on the robot arm, and the robot arm is moving them down for the highest place in the cargo bay that they could ever be. We're going to take a short break as they come back down in the cargo bay, and we'll just have to watch and see what happens next. Stay with CNN for live coverage from Endeavour. Two spacewalking astronauts, Story Musgrave and his partner Jeff Hoffman, now coming back down into Endeavour's payload bay. They've been out in space for more than 6 hours now. There's some concern on the ground that they've been out there a lot longer than they had counted on. This was expected to be a 3-hour spacewalk with a little time left over to watch the solar panels unfurl, but because they had some trouble with the first of their many jobs that they had to do in this nighttime spacewalk, they got somewhat behind schedule. They're back on schedule now, but their ground managers want them to get down in the payload bay and prepare to come into the airlock, despite the fact that the solar panels have been recalcitrant in the past from unfurling. Michael Schara of the Space Telescope Science Institute in Baltimore is joining us here at the CNN Center to offer commentary on what's about to happen and what is happening so far. The shuttle's still in darkness. It'll be back in sunlight in a matter of a couple of minutes. We have more calls on the line with us. The next one from California. Go ahead. You're on CNN.
Hello?
Hi, you're on.
Yeah, hi. John Farian here from Los Angeles. In an obscure article that was actually a cover article in September 1961, Palomar had discovered an exploding galaxy. I believe it was called M81. Has Hubble investigated it, and has there been any information about that thing since?
Sure, I can respond to that. Let me just add one digit. It's M82. M82 is a companion galaxy to M81, and it appears to be the closest example of what we call a starburst galaxy. It's a galaxy where enormous numbers of brand new stars have been born, perhaps because of a tidal interaction with M81, its parent galaxy. It does appear to be an exploding, erupting galaxy, and it certainly is an object that's on Hubble's list for observations in the coming year. If we do get a break in the picture sometime in the next few minutes, we do have another picture of an active galaxy, another active galaxy taken with the Hubble telescope, which will show a similar sort of activity, both from the ground and the Hubble Space Telescope view.
Well, the astronauts look like they're having a pretty good time at this moment. Michael, I'll keep watching them. Why don't you show our viewers that new picture that you brought with us?
Okay. If we can bring up that graphic, the third to last one. This is Okay, this is in fact the Hubble Space Telescope view of the nucleus of an active galaxy. The bright whitish spot almost near the center of your screen is the very center of the galaxy, and it's clear that there's some violent activity going on, material being spewed out from the very center. It's a very open topic of controversy. What the center is, what the source of energy is, we'd very much like to know that.
All right, our next caller is from Ohio. Go ahead, you're on CNN. We'll go back to our live picture now, I think.
Good evening. Those pictures about a half an hour ago from over Australia were absolutely spectacular.
No kidding.
I'm sure Mr. Hubble, as well as Newton and Kepler and Einstein, would be quite proud of their descendants. My question is this. On an earlier space shuttle mission, I recall that they retrieved a satellite from space, brought it back to Earth, and repaired it and relaunched it. I was wondering why they didn't do that with the Hubble.
That certainly was the initial plan. The idea was to launch the Hubble telescope and then bring it back every 4 or 5 years for repair and refurbishment. It certainly would have been easier on the astronauts had that been possible or easy. But it became very clear late in the construction of the telescope that it was going to be very difficult, and also that the chances of contaminating the telescope were very severe. Bringing the telescope into the shuttle bay, which is a fairly dirty environment, and especially subjecting it to all the stresses of re-entry, was going to be dangerous for the telescope and potentially dangerous for the astronauts. This really is the best way to go. We're very happy with the telescope where it is, and especially since the astronauts can get up there and fix it, we'd like them to keep visiting it on a regular basis and doing the repairs in space.
As the astronauts move down into the cargo bay now and stow the equipment that they have been using on this spacewalk and attempt to clean house at the end of what may well be their final spacewalk, Michael, at the beginning of this mission, before it launched, how sure were you that a team of astronauts in spacesuits were going to be able to fix this telescope and keep it maintained?
NASA kept maintaining that the astronauts were thoroughly trained. We saw video of them working in the water tank, which is the closest simulation you can get on Earth. These people were incredibly highly motivated and trained, and we firmly believe that if it was at all possible, they would succeed. But there was just no way of knowing, and seeing is believing. These people have pulled off what to me was an incredible job, a very, very difficult job. I think that the astronomical community of the world, and perhaps all of the world, owes them thanks for this really, really wonderful job that they've done.
Story Musgrave and Jeff Hoffman continue to work out in the cargo bay, doing some final work on the Hubble Space Telescope. When they started their first spacewalk, they covered up a great number of the instruments on the bottom of the telescope to prevent those instruments from being damaged, including a low-gain antenna. They are now uncovering that low-gain antenna in anticipation of the telescope's relaunch into space. We're going to take a quick break as they continue to do their work. We'll come back with more live pictures from Endeavour in just a moment. Stay with CNN. Welcome back. If you look on the left side of your screen, you'll see something that looks like the point of a spear. That pointed object on the bottom of the Hubble Space Telescope is a piece of equipment known as the low-gain antenna. It is sharp-pointed. Imagine what it would do to a spacesuit. Because of that, the antenna, the first thing the astronauts did when they went out into the cargo bay was to put that white cover that you see on top of that low-gain antenna to keep it from being damaged and to keep them from being damaged by the pointedness of the antenna, because they're preparing to stay out of to get out of the payload bay and stay out. The astronauts are now removing that cover. It'll be stowed in the locker where you see Story Musgrave moving toward right now. While we were in our commercial break, the sun came up, as we told you it probably would at about this time, and the astronauts have the reflection of sunlight from the Earth over their heads now as they continue their work. This is the view from a camera at about 25 feet down the robot arm, looking at Story Musgrave as he continues to stow equipment in the payload bay of the shuttle. You see Jeff Hoffman over on the right of your screen underneath the Hubble Space Telescope. He is putting tools away as Musgrave is preparing the telescope for its relaunch into orbit. We have some more phone callers joining us now. We have a caller from New York. Go ahead, you're on CNN.
Okay, my name is Steve from Queens, New York, and I'm glad to be on your program tonight.
Thanks.
Okay, I'd like to first say that I believe more in the creation of the universe rather than Big Bang Theory. And I think that there's a lot of good science out there that just supports that. My question to you would be, what don't you expect to find with the Hubble, or rather, what would you find that would kind of question the Big Bang? And the reason why I ask is some time ago, some astronauts were making a 3D map of the universe using 2 telescopes rather than the red shift. And they found these absolutely huge gaping holes in the structure of the universe. And one of them surprisingly said that they would have to kind of rethink the Big Bang theory. So what don't you expect to find out there with the Hubble?
You've asked a couple of questions here. You were referring to the so-called voids. There are regions, large regions, many millions of light years across, which are almost devoid of galaxies. The reason we think that's happening is because as the universe expands, there are places in the universe where there are a few more galaxies than others, a slight density enhancement, and the rich tend to get richer and the poor tend to get poorer when it comes to galaxy clustering. The more galaxies you have in a place, the more gravity you have, and that tends to drag in more and more galaxies. Well, those galaxies that get dragged into a certain volume of space do so at the expense of other volumes of space, and that we think is how the voids in intergalactic space get made. As for the correctness or not of the Big Bang, it's certainly not an absolutely open and shut question. There are certainly other interpretations that are available. On the other hand, the absolute uniformity of the microwave background radiation that's recently been measured is a strong indication that the universe did start from a very, very small, dense state and has been expanding outwards, as are the redshifts of the galaxies. So while it's not 100% proved, and while it's almost impossible to prove anything in science, I would say that most astronomers are supportive of the Big Bang theory, and there are no gaping holes in the theory right now.
All right, our next caller is from Pennsylvania. While we wait for that call, I will tell you that Story Musgrave is moving back to the airlock with his portable tool kit. He's going to begin shoving tools into the airlock to get them out of the cargo bay. Pennsylvania, go ahead. You're on CNN.
Thanks for the great coverage. Jay Good, Pittsburgh. The backpacks, how long does it take to recharge or regenerate those? I assume there's one for each suit?
There's one for each suit, that's right. And the battery power in them is good for about 8 hours. It takes an overnight period to recharge them. The oxygen can be recharged from the airlock itself, so that when the astronauts get low on oxygen, they just go into the airlock and fill up their tanks, which gives them another 5 or 6 hours worth. So that's how that works.
Any reason they don't work 2 shifts?
2 shifts at a time? Yeah, they want to make sure that the astronauts who are out there have had a day's rest before they go out. We've lost our live picture from space, or we did for a moment. There's another view from a camera showing the bottom of the space telescope. It appears that the shuttle is moving out of satellite range right this minute. We don't know whether it'll be back or not, but we're going to take a break right now, and we'll try to find out. Stay with CNN's coverage of the mission of Space Shuttle Endeavour.
Tomorrow, Endeavour's astronauts are to boost the Hubble Space Telescope back into orbit. It'll be weeks, though, before the shuttle crew finds out if its hard work is all paid off or not. Crew members made their last spacewalk in repair of the Hubble overnight. CNN's John Holliman has that.
After 4 spacewalks that seemed to go like clockwork, the final night in Endeavour's cargo bay was filled with surprises.
The day reminded me kind of a lot like the first EVA day, because we were getting so close to the finish line, and you could see it, and you didn't want to stub over your own toes.
First, the astronauts had trouble disconnecting a solar array electronics box. It was packed with computer cables, and one of them proved difficult to remove. Then, the solar panels wouldn't move down into position to be unfurled. The electric motors were not strong enough to move them. But astronaut Story Musgrave and his partner, Jeff Hoffman, made it look easy.
Story, we got a great view of you from the elbow camera if you want to take a look and give us a wave.
Like my note said to everyone down there, that all you EVA folks, you're in our hearts, you're in our hands. What we've done and what we're going to do is simply a reflection of what you're giving to us.
The astronauts ended their night on top of the telescope, putting caps on the magnetometers to prevent any debris from the instruments from getting into the telescope barrel. The spacewalkers spent a little extra time above the Earth, looking down at Australia from more than 300 miles up.
Yeah, you can see the entire continent of Australia from here. See this? The whole thing. I swear, you can see 3,000 miles from here.
As they packed their tools and other equipment for the return to Earth, ground controllers sent a signal to the solar panels to unroll and begin generating electricity. The process went very smoothly. While the panels unfurled, the astronauts climbed back inside the crew cabin in preparation for release of the telescope, which will happen before dawn on Friday. John Holliman, CNN reporting.
Well, NASA astronaut David Wolf says a neighbor, and not the FBI, organized a whining and dining night on the town to convince him to get NASA interested in a bogus medical device. The FBI was using the device in its sting operation to undercover corruption at the space agency. Wolf says his neighbor, an aerospace worker, believed the device was real. Wolf says the FBI did nothing wrong.
There's many good points to this investigation. It established that I would decline all advances. It established the integrity of our astronaut office. I think the FBI agents and the Inspector General have done their investigation to the best of their ability. Their agents have performed just like we in the astronaut office performed to the best of our ability.
Investigators have told NASA that Wolf did nothing wrong.
Beim letzten Ausstieg siegte die Handarbeit über den Computer. Die Astronauten Musgrave und Hoffman mussten die Masten der Sonnensegel mit einer Kurbel ausfahren. Die Bodenstation hatte es zuvor nicht geschafft. Am Montag landen die Astronauten wieder auf der Erde. Ob sich ihre Arbeit gelohnt hat, werden sie erst in 6 Wochen wissen. Dann zeigt sich nämlich, ob Hubble das Weltall jetzt mit klaren Augen sieht.
5-mal mussten die Astronauten der Endeavour aussteigen, um das Teleskop Hubble zu reparieren. Der letzte Aufenthalt war auch der anstrengendste. Fast 7,5 Stunden dauerten die Außenarbeiten. Abschließend nahmen Story Musgrave und Jeffrey Hoffman die letzten Arbeiten an den Sonnensegeln vor. Allein für das Auswechseln der elektronischen Teile, die die Sonnensegel antreiben, wurden 3 Stunden gebraucht. Das war doppelt so lange als geplant. Die Sonnensegel haben eine Fläche von 70 Quadratmetern und eine Leistung von 4,5 Kilowatt. Sie sind außerdem stärker abgefedert und besser isoliert worden als ihre Vorgängerinnen. Bei den Reparaturarbeiten im All gingen 3 Schrauben verloren. Doch den Astronauten gelang es, sie wieder einzufangen und damit weiteren Weltraummüll zu vermeiden. Mit 2 Kurskorrekturen wurde die Raumfähre Endeavour auf eine höhere Flugbahn gebracht. Dort soll dann in wenigen Stunden das Weltraumteleskop Hubble ausgesetzt werden. Die Landung des Shuttles ist für Montag vorgesehen. Mit den 5 Aufenthalten im All hat die Mannschaft der Raumfähre einen neuen Rekord für Shuttleflüge aufgestellt.
Die Astronauten der amerikanischen Raumfähre Endeavour haben ihre Reparaturarbeiten am Weltraumteleskop Hubble abgeschlossen. Mit mehr als 35 Stunden Aufenthalt im All bei 5 Ausstiegen stellten sie einen neuen Rekord auf.
Noch einmal winken aus dem Weltraum, dann ist es vorbei. Nach 5 Arbeitsausflügen ins All ist die Reparaturmission für das Hubble-Teleskop erfolgreich beendet. Das Riesenteleskop wurde technisch rund erneuert, 11 Ersatzteile eingebaut, auch die Sehunschärfe durch Korrekturlinsen behoben. Und auch die neuen Sonnensegel, die die Stromversorgung von Hubble sicherstellen, wurden wieder ausgerollt. Der letzte Ausflug war allerdings überraschend der schwierigste. Der Einbau von Elektronikteilen dauerte doppelt so lange wie geplant. Lockere Schrauben mussten wieder eingefangen werden. Aber am Ende klappte es dann doch. In der kommenden Nacht soll Hubble wieder von der Raumfähre getrennt werden. Erst in 6 Wochen wird man wissen, ob alle Instrumente an Bord auch wirklich funktionieren. 15 Jahre lang soll Hubble dann noch den Ursprung des Alls erforschen. Die Astronauten jedenfalls haben alle Aufgaben erfüllt. Es war ein Erfolg, den die NASA dringend brauchte. Denn die Astronauten haben gezeigt, dass man im Weltall auch umfangreiche Bauarbeiten durchführen kann. Voraussetzung für den Bau einer Raumstation, die die Amerikaner jetzt zusammen mit den Russen errichten wollen.
Eine Sondersendung zur Hubble-Reparatur können Sie heute Abend um 23 Uhr nach den Tagesthemen sehen.
During the mission, the crew set an American record with their 5 spacewalks. They've completed all the tasks set for them, but as Fiona Dodd reports, it'll be several weeks before scientists on Earth learn whether the Hubble repairs have been successful.
The 5th spacewalk of the mission to repair the Hubble telescope turned out to be the most difficult. Astronauts Story Musgrave and Jeff Hoffman's first task was to remove and replace the solar array drive electronics. This allows the solar array panels on the telescope to swivel, capturing radiation from the sun, which is then converted to electric power. This went smoothly. Story Musgrave even found time to wave to the crew.
Story, we got a great view of you from the elbow camera if you want to take a look and give us a wave.
Next on the list was wrapping thermal insulation around the new magnetometers.
Back to the top of the telescope, Story Musgrave and Jeff Hoffman again to install some fabricated insulation boxes over the old magnetic sensing systems as the orbiter moves up the northwest coast of Australia.
Finally, the 40-foot-long golden wings of the solar panels were slowly unfurled, but only after the astronauts intervened to release 2 solar panel arms. Motors operated by ground control failed to work, and the arms had to be pried loose. The refurbished telescope will return to orbit early on Friday morning. So far, the mission has been deemed a complete success, but NASA scientists won't be able to relax until the new images from the Hubble reach Earth in about 6 weeks' time.
5, 4, 3, 2, 1. And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
Es war der 59. Start einer amerikanischen Raumfähre, aber es war alles andere als Routine. Eine ehrgeizige Mission, so nannte sie auch die NASA. Die 7 Astronauten sollen nicht nur ein kurzsichtiges Teleskop reparieren. Hier geht es darum, den guten Ruf der amerikanischen Weltraumfahrt wiederherzustellen. ...500 Kilometer über der Erde will die NASA zeigen, dass die bemannte Raumfahrt noch eine Zukunft hat. Das Hubble-Teleskop, groß wie ein Autobus, $2 Milliarden teuer. Vor dem Start vor 3 Jahren der Stolz der Wissenschaftler, das leistungsfähigste Teleskop, das je im Weltraum platziert wurde. Und dennoch ein Fehlschlag. Das Teleskop ist kurzsichtig, ein Produktionsfehler, der zu spät bemerkt wurde. Das Ergebnis waren Bilder wie diese. Unscharfe Aufnahmen aus der Tiefe des Alls, Folge eines Spiegels, der um Bruchteile eines Millimeters falsch geschliffen worden war. Das Hubble-Teleskop konnte nur einen Teil seiner Aufgabe erfüllen. Ein schmerzlicher Schaden für die Wissenschaft, ein schwerer Prestigeverlust aber für die NASA in einer Zeit, in der sich auch in Amerika immer mehr Menschen fragen, warum man Milliarden Dollar für die Weltraumfahrt ausgeben soll. Die Wissenschaftler tüftelten eine Lösung aus, um den unscharfen Spiegel zu korrigieren. Sie entwickelten diese Linsen, die das in das Teleskop einfallende Licht so bündeln können, dass am Ende wieder scharfe Bilder dabei herauskommen. Dem Hubble-Teleskop sollten sozusagen Kontaktlinsen eingesetzt werden, um die Sehunschärfe zu beheben. Doch bevor es hoch hinaus ins All ging, tauchten die Astronauten erst einmal tief unter. In einem Wasserbecken simulierten sie den Einsatz in der Schwerelosigkeit an einem Hubble-Modell. Vorbereitung auf eine Mission, in der nicht nur die Sehunschärfe behoben, sondern das Teleskop insgesamt technisch gründlich überholt werden sollte. Diese 7 Astronauten sollten als Klempner im Weltall Hubble wieder auf Vordermann bringen. Eine gemischte Truppe, eine Frau, 6 Männer, darunter ein Schweizer. Und dann war es soweit. Aus dem Dunkel des Weltraums tauchte Hubble vor dem Kabinenfenster der Raumfähre auf. Der Schweizer Claude Nicollier, der für die Europäische Weltraumagentur mit an Bord ist, hatte die schwierige Aufgabe, den Roboterarm zu bedienen und das riesige Teleskop einzufangen. Präzisionsarbeit, während die beiden Raumfahrzeuge mit 17.500 Meilen pro Stunde durch das Weltall rasen. Geschafft. Hubble ist festgemacht. Story Musgrave und Jeffrey Hoffman sind die ersten aus der Klempnerriege.
Hello, Jeff.
Ein letztes Winken für die Lieben daheim. Und dann steigen sie durch die Druckschleuse aus zu ihrem Arbeitsplatz im All. Die Aufgabe klingt einfach. Tür öffnen, Ersatzteile einbauen. Alles wurde monatelang geübt. Doch in den unförmigen, klimatisierten Raumanzügen dauert in der Schwerelosigkeit des Alls jeder Handgriff unendlich viel länger. Lassen sich Arbeitsabläufe nur in Zeitlupe ausführen. Hier werden neue Steuerungselemente eingesetzt. Das eigentliche Problem kam, als an diesem ersten Arbeitstag im All schon alles vorbeischien. Das scheinbar einfachste, das Schließen der Tür, klappte nicht. Durch die Sonneneinstrahlung hatten sich die Türflügel verzogen. Da musste improvisiert werden. Nicht alles lässt sich eben vorplanen. Über 2 Stunden schufteten die Astronauten, bis die Tür endlich zuging, die mit einer Art Gürtel zugezogen werden musste. Gute Arbeit, bestätigt die Bodenstation. Profis bei der Arbeit, Veteranen der NASA, 46 Jahre ist das Durchschnittsalter. Alle Astronauten haben Raumflüge schon hinter sich, so auch Catherine Thornton. Die 41-jährige Physikerin ist Mutter von 3 Kindern und hat unter anderem in Heidelberg studiert. Von ihr wird man auf dieser Mission noch viel hören. Rund 600 Kilometer über der Erde. Catherine Thornton hoch oben an der Spitze des Roboterarms, unter ihr Thomas Akers. Beide sollen an diesem zweiten Arbeitstag im All die Solarflügel auswechseln, die das Hubble-Teleskop mit Strom versorgen. Bevor die neuen Solarzellen angebracht werden, müssen die alten, bereits eingerollten 12 Meter langen Flügel abgebaut werden. Diesen werden die Astronauten mit auf die Erde zurückbringen. Dieser zweite, stark beschädigte Flügel jedoch geht über Bord. Catherine Thornton entlässt ihn in die Tiefe des Alls. Weltraummüll, Zeichen dafür, dass sich der Mensch auch in diesen Höhen auszubreiten beginnt. Hoch oben über Somalia setzt der Sonnenflügel seinen Tanz fort, bis er irgendwann in einem Jahr verglühen wird. Nach der Anstrengung Entspannung. Catherine Thornton und ihr Partner Thomas Akers.
And we're with you on the flight deck.
Du siehst überhaupt nicht angestrengt aus. Du siehst so aus, als ob es leicht gewesen wäre, sagt die Bodenstation. Es war einfach, sagt Catherine. Die Besatzung bereitet sich auf den Schlaf vor. Mit 7 Astronauten wird es eng an Bord der Raumfähre. 8 Stunden Schlaf werden den 7 im All zugestanden. Und das Kontrollzentrum versucht, das Aufwachen mit Musik so munter wie möglich zu gestalten.
Yeah, that's what we thought too. Good morning.
Es ist Mittwoch, der entscheidende Tag für die Hubble-Mission. Catherine Thornton balanciert den Behälter, auf den es ankommt. Er wiegt auf der Erde über 200 Kilogramm. Hier in der Schwerelosigkeit lässt er sich mit einer Hand dirigieren. Bei diesem Arbeitsgang soll das Teleskop seine neuen Kontaktlinsen bekommen, die die Sehschärfe wiederherstellen sollen. Sie sind in diesem Behälter eingebaut. In der Nacht zuvor hatten die Astronauten bereits mit Erfolg eine neue Hochleistungskamera eingebaut. Auch diesmal klappt es ohne Probleme. Ein Seufzer der Erleichterung, sagt die Bodenstation. Trotz aller Erfolgserlebnisse, es bleiben die Überraschungen. Und da musste immer wieder improvisiert werden. Hier zum Beispiel stellen Claude Nicollier und Kenneth Browersox per Handarbeit eine Isolierabdeckung her. Sie wurde in der vergangenen Nacht von Story Musgrave und Jeffrey Hoffman angebracht. Die alte war im All zerfallen. Spacewalk, Spaziergang im All nennen die Amerikaner diese Ausflüge. Aber von Spaziergang kann hier keine Rede sein. Dieser letzte Arbeitsgang ist überraschend der anstrengendste. 3 Stunden, doppelt so lange wie geplant, brauchten die Astronauten, um die Elektronik einzubauen, die die Solarflügel antreibt. Schließlich gelang auch das. Während die Besatzung aus dem Cockpit zuschaut, entfalteten sich draußen wieder die Sonnensegel. Ein entscheidender Moment, denn die Solarzellen sorgen für den Strom im Teleskop. Am Ende ein zufriedenes Winken von Astronaut Musgrave. Nach 5 Ausflügen und insgesamt 31 Stunden Länge ist die Klempner-Mission im All abgeschlossen. 11 Ersatzteile wurden eingebaut, das Hubble-Teleskop technisch erneuert, Fehler behoben. Stolz, vor allem aber tiefe Erleichterung im Kontrollzentrum in Houston. Die NASA stand unter einem erheblichen Erfolgsdruck. Nach einer Reihe von Rückschlägen musste es diesmal einfach klappen. Und die Weltraumbehörde musste beweisen, dass umfangreiche Arbeiten im All überhaupt möglich sind. Der deutschstämmige Chef des Büros für die NASA-Zukunftsplanung betont:
Ja, auf der einen Seite als Ingenieure haben wir damit den unzweifelhaften Nachweis geliefert, dass die bemannte Wartung und Versorgung von komplexen Systemen im Raum möglich ist. Das lässt sich hinfort nicht länger bezweifeln. Und auf dem wissenschaftlichen Gebiet haben wir damit ein Teleskop instand gesetzt, das uns den Kosmos eröffnet, bis, wie wir immer sagen, zum Rande der Zeit.
Das Ganze war also ein Testlauf, auch für die neue Space Station, für die neue Weltraumstation.
Ja, wir haben mit der kommenden Raumstation komplexe Herausforderungen zu erwarten. Und die Hubble-Reparaturmission und Versorgungsmission war eine kritische Hürde, die uns die Zuversicht gibt, dass wir auch die Raumstation, die Montage der Raumstation gut über die Bühne bringen können.
Noch arbeiten die Amerikaner zwar alleine, aber schon 1997 wollen sie zusammen mit den Russen mit dem Bau der Raumstation beginnen. Die Hubble-Mission war ein wichtiger Schritt dorthin. Das Riesenteleskop ist nun technisch runderneuert. In der kommenden Nacht soll es wieder von der Raumfähre getrennt werden. Erst in 6 Wochen wird man wissen, ob alle Instrumente auch wirklich funktionieren. Bei der NASA herrscht Optimismus.
One of the key projects
Das Hauptziel für Hubble ist, die Ausweitung des Universums zu studieren, um festzustellen, ob das immer so weitergeht, ob es langsamer wird oder einfach in sich zusammenfällt. Die Astronauten haben ihre Arbeit getan. Das Teleskop soll noch 15 Jahre lang das All erforschen. Mit der neuen Brille kann Hubble noch Licht in Galaxien messen, die 50 Millionen Lichtjahre entfernt sind. Es wird der Entstehung des Universums nachspüren und damit letztlich auch dem Ursprung dieser Welt, auf der die Menschen leben, die immer noch fasziniert auf den gestirnten Himmel über uns schauen und sich fragen, wo diese Welt eigentlich herkommt.
Endeavour's moving towards sunset, about 5 minutes away from moving into the night side of Earth.
80 inches of tether is really something out here.
Okay, and no more than 100 degrees on the opening, right, guys?
Right.
Okay, I'll steady the door, Jeff. Okay. I have the door.
Let me go put this on the telescope first.
I have the door. Stop, please, Claude. Stop.
The power tool came out of the bayonet fitting slid open. I got it.
Hey, Store.
Yes?
What do you think about you putting your tether on to hold the door from not going open any farther before Jeff puts his on?
Okay. I'll stand by here.
But I had a firm grip. You see this? Yeah, but understand. Okay. Now 80 degrees we're aiming at. Claude's going to bring you down to it. Take it easy. Take it easy.
Take it easy.
I take you down slowly, Jeff.
It's stable. It's coming down pretty fast.
Yeah, he's going to catch up with it.
I have it.
Okay, arm stops.
Great success.
Good job. Ultimate arm driver.
It's good read back, Cubby.
Wrapped around the bottom. Let me hold the other one, Troy, and you can work on it. I have it.
In progress, the manual deploy of the second solar array down to the open position. The secondary drive mechanisms that actually roll out the new solar array blankets is not done until after this EVA is completed, or this spacewalk. The payload community commenting that they are relieved to see this solar array being opened.
Endeavour Houston, the GHRS is ready and awaiting.
Okay, thanks a lot, Greg. Copy, Story? Yeah?
The Space Telescope Operations Control Center has turned off any electrical connections or electrical power to the Goddard High Resolution Spectrograph and The crew's been given a go to install the redundancy kit, the cabling kit that was designed for this task. Once they get the doors open, there's 4 latches on the doors that protect the instrument, along with the faint object spectrograph.
I can do the bolt. You want me to do the bolt? If you can do the bolt, it's much better to put 23 foot-pounds from the MFR than for me with my feet flailing around in here. I'll do the bolt. I'll move out of the way. Pitch me down into cavity, please, Claude. 23 PT4, Titan. Now into the cavity, Claude. Out of your way, okay, inside. Stop, please. No. Stop, Claude. Stop. You want me to stay 90 right, Claude?
No, you can stay if you are. Let's say 0 degrees will be fine.
Ready? I'll wait till Jeff gets off, of course. Okay. Okay. Can you bring me down now, please, Claude? I gotta do the handle bolt. Tighten it up first.
Okay, down.
Have you looked at this, Jeff? Yep, just take one look at this. Oh, my goodness.
Back to the top of the telescope, Story Musgrave and Jeff Hoffman again to install some fabricated insulation boxes over the old magnetic sensing systems as the orbiter moves up the northwest coast of Australia.
370 miles away.
And Kyle, those 2 gentlemen on the end of that arm are having the view of their lives right now, looking over the top of the scope down at the Earth. You heard Story even remark about it. I could tell you this is probably a moment they'll remember for many, 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 many years to come.
Here comes one. Okay, I'll take the needle nose pliers caddy. Here's a...
And we have got an unbelievable picture from the elbow camera right now.
Pretty impressive, isn't it?
The Australian Sharks Bay. This is something else. The India Ocean. Oh my goodness. Hey, inch up, Jeff. You can see the entire continent of Australia from here. See this? The whole thing.
Endeavour Houston, we're ready for free drift, and we need a camera view of the array, please. We do not want to delay, and we do not want to delay the egress of the MFR, however.
Roger, I understand. We'll get the elbow camera back over on the array, and we're going free drift.
Roger.
Story, check up to your right.
Slick. Really nice. So good. All right.
Hey, so Jeff, you're going to head in and help Story here at the airlock, right?
I am on my way.
Okie doke. Big T101's good, I'll mark it off.
if you could give me vectors, because we don't have the camera. We have the camera on the solar array now.
Okay. Oh. Okay.
The second solar array wing process of being deployed as Endeavour moves off the southeastern coast of Madagascar. Again, the flex in the arrays is designed to account for any tolerances in movement of the solar arrays.
That's a good separation, no?
Yes.
The high-gain antenna deploy is in progress aboard Endeavour and aboard the Hubble Space Telescope. This is a simultaneous deploy of both antennas, one on this side of the telescope and one 180 degrees around on the back side of the telescope. And this is about a 7-minute in duration process, very slow and deliberate.